Yeah, got it.
Alrighty, everybody. Good evening, and welcome back to the Divestream. You are watching a live camera feed from ROV SuBastian, which is, of course, tethered to RV Falkor 2. And good morning, good afternoon, and good evening, wherever you may be tuning in from. This is Dive 785, I think, right? Yes, 785. And we are back yet again for another dive. And here with me in the control room, I've got some wonderful pilots. I've got Joelle and Andy at the controls today. And then I've also, Joelle's giving a wave, but you can't really see. Yep, feel free to post any questions you have in the chat. We've got a lovely team of scientists, a multidisciplinary team of scientists ready to answer all of your questions. And one of those lovely scientists is sitting up front here with me, and she's going to introduce herself right now. Take it away.
Olá, boa noite. Boa noite, yeah. I think it's boa noite in Portuguese. But I think it's back home it's already evening. And my name is Sofia. I'm a deep sea biologist from the University of Aveiro in Portugal. One of the several biologists on board. We do have quite a big range of expertise. And together with me, I also have Andres Veloso, just behind me. He usually does not want to talk much, but maybe we can try today. This expedition, as you may know or not, it's part of the climate connections at the sea ice interface. It's an expedition that has already gave us quite a lot of enthusiastic observations. We are right now under a location that was until very recently completely covered by ice shelf on the George VI R shelf, and we will continue exploring different kinds of topographic features from the seafloor that we have been undecisively trying to choose between so many good spots we wanted to try. The goals are to characterize these locations in the best way possible. That's why we have so many people on board with different kinds of expertise and from the geology. So we're going to pick rocks, for example. We're going to pick sediments as well for the characterization of both, for example, granulometry, organic matter, the communities that they live in there.
RV bridge, do you want me to get underway?
Yeah, just stand by. We're just jogging off to the other line to go look at something. I'll give you a wave.
Okay.
Namely some small organisms like the meiofauna up to the large stuff that we see on the video, the megafauna, what we call the megafauna. There's also going to be studies on food web, for example. So there's going to be quite an interesting overview of these locations in terms of biological, but also geological and geophysical characterization and oceanographic, because we also have, in addition to Sebastian, some colleagues doing some glider work for having a better idea of the big currents and water masses that are influencing these sites. Yeah, I think that's mostly it for now. We're going to start exploring a little bit this location. We are a bit off track, just to have a quick look on the side area, and then we're going to go back to our path and see if we upwards and see what we see as
So that's over 100 meters from our first one.
okay. Can we start? Yeah, we can start going back towards the waypoint 2. Yeah.
Okay. bridge, ROVs. Updated waypoint, please.
Updated waypoint. What sort of speed are you looking for? 0.4?
Yeah, sure. We'll start out that. We're probably going to have a pretty good steep climb, so I'll probably... Yeah, 0.4 is fine. We're going to have a pretty steep ascent at some point, so I'll probably pause you while we move up the rock face.
Okay, understood.
It's an anemone. And a crinoid, yeah. And a lot of sea fauna is very close to the seafloor again. We saw that on our first time here. Possible to go slightly closer to the seafloor, just to get a better view. Thank you.
Oh, me too.
Yeah, enough. Although this is upslope, so it might be more tricky. So like this is good. Like this is actually perfect. I know we are a bit sideways as well. side. Yeah.
This guy's up here. Ready to draw, ROV?
Yeah, go ahead.
Yeah, can we increase to a 0.6, please?
Yeah, will do.
Thank you. Probably slow down. Huh.
Yeah, it's a rocket. Not what we're looking for. We're looking for bigger stuff. You know, it's like, well, well, they're not necessarily looking. We're just, it's a perfect rock. A few days ago, we were looking for rocks and we didn't get any, remember? So, just toward the ends of the day. You can feel it. We're reaching waypoint 3 soon. No, 2. So it's gonna be... still have a good slope up there, yeah. You feel it, Andres. I think you feel it well. Zoom in here. No, it's okay, it's okay. I can see it's a sea urchin that it's covered. Yeah, it's okay. Yeah, thank you. Nice. Nice.
See? Hey.
Oh wow,
So it's on the
that it does. I think it's similar to the ones we saw on our first dive. Just kind of anchored on the sediment. Yeah, it does seem like it. Thank you. That's great. Sponge. Mm-hmm. It's home of several shrimps.
shrimp inside.
Mm-hmm. Yeah, you can see it inside.
Still looking at this? Or?
Yeah, we can move on. I'm just
Moving on?
yeah, we can. I'm just having a quick look at the
Fish.
Can we have a zoom? Just have a quick look. It's mostly the same. It's mostly, yeah, sponges. Oh, there's a nice isopod. And a sponge. It's okay, we can continue. Can we continue slightly to the right side?
Voyage ROV.
Go ahead.
Yeah, can we reduce speed to 0.4 and update it?
Copy that.
Oh, nice. That's a beautiful sea star. Hmm? Do you want it? Okay. After we zoom in, we would like to collect one of the rocks. And while we... Oh, that's really nice.
Voyage ROV, can we pause and move, please?
Pausing move.
Oh, that's a beautiful polychaetes are totally out. It's so cool. The serpulites. It's really nice. Yeah, thank you. I'd like to pick up that one that seems to be loose. Sorry?
No.
On the buy box too. Too much current?
No.
Oh, okay.
No. Sorry, man. All right. Far away.
Nice.
All right.
Yeah, for BB2B,
We need to be.
can we just have a quick zoom as well?
Yeah, we're sure.
Yeah, perfect.
Watch it out.
Some sea pigs just flying down. Yeah, that's all we want.
Joel, is that not all the way on the porch?
No, but
Just go all the way out the porch. Okay.
Let's see. Which one do you want it?
2B. Thank you.
That's That's it for here, right?
All, yeah, all. Just trying to look at the map. Yeah, let's try to pass by that little dark green area.
What's your name?
I'll let you get ahead of it. Dream team. Anybody want a break? You guys have time? Fine. You want-
Oh, fine, or what? I don't know.
Hang on a second.
Half an hour.
Oh, it's easy.
Half an hour, maybe.
Yeah.
So much to go to the black shore, huh?
Yeah, where's the mouse right now?
Is it alright if I turn that waypoint to get the waypoint here?
Yeah, it's okay. That's perfect.
And the rest. Bridge ROV, that's an updated waypoint, please.
Updated waypoint.
Bueno, hola a todos y bienvenidos a un buceo más aquí en lo más profundo del mar de Bellinghausen. Mi nombre es Patricia Esquete, soy jefa científica de esta expedición, trabajo en la Universidad de Aveiro y voy a estar comentando junto con Cristian Aldea de la Universidad de Magallanes por lo que vamos encontrando en esta inmersión tan interesante. También nos acompaña Sasa Montelli del London University College y Leslie Novoa de la Universidad de Magallanes. Este es ya el cuarto buceo que realizamos en esta zona, que es muy interesante porque corresponde a una zona que hace apenas una semana estaba completamente cubierta por una capa de 200 metros de espesor de hielo. Esa plataforma de hielo, una parte de esa plataforma de hielo se desprendió en forma de iceberg y dejando abierta una zona completamente nueva para ser explorada. Y eso es lo que hemos decidido hacer, venir a explorar esta zona. Hasta ahora hemos encontrado, bueno, hay que decir que por lo tanto todas las inmersiones que hacemos en esta zona es básicamente lo mismo que si estuviéramos buceando debajo del hielo. Porque es un hielo que ha estado formándose y ha estado allí durante cientos de años.
Great, ROV.
ROV bridge.
Can we increase speed to 0.4, please? Or, excuse me, 0.6.
0.6.
Thank you.
Lo que hemos encontrado hasta ahora ha sido muy interesante. Hemos encontrado unos ecosistemas muy ricos, o sea que no sabíamos exactamente qué esperar, porque lo que ocurre debajo del hielo, cuando tienes encima una capa tan espesa de hielo, lo que ocurre es que los nutrientes que se forman en superficie debido a la fotosíntesis, a través de algas fotosintéticas que viven en la columna de agua y sobre todo cerca de la superficie, y en el fondo lo que hacen es transformar esa luz en nutrientes que al final acaban llegando al fondo del mar. Ese es el proceso normal. Ese proceso no puede ocurrir si tienes por encima una capa de 200 metros de hielo, entre 100 y 200 metros de hielo. Por lo tanto, sin esa fuente directa de nutrientes nos estamos preguntando qué clase de ecosistema nos íbamos a encontrar o si íbamos a encontrar alguno.
ROV bridge.
Go for ROV.
Yeah, just a question for you. There's a lot of ice coming on the starboard side. Would it be feasible for you guys if we rotated the ship 180 degrees?
We'd have to get over on the other side. We can do it.
Okay, stand by. Just still assessing. I just wanted to know if it would be possible.
Yeah, we'll just have to drop the ROV back, have you spin around and get ahead of us.
Copy that. All right, let's just continue on for now. I'll let you know.
ROV copies.
Últimamente momento acaban de avisar que una fuerza presente por el lado de Tibor, por tanto, tener la precaución de lo que es, ¿verdad? Patricia, estamos navegando buceando prácticamente bajo el hielo, monopolizando prácticamente bajo el hielo, monopolizando hace un par de días atrás, en cuanto a la fauna y esa composición para la comunidad que existe.
Sí, estaba contando que no sabía muy bien lo que esperar porque estas son comunidades que no reciben, que no han recibido nutrientes directamente de la superficie, que se forman en la superficie, a través de la superficie, que se forman en la superficie, a través de la fotosíntesis que realizan las algas cerca de la fotosíntesis que realizan las algas cerca de la superficie, que sería el proceso de la superficie, que sería el proceso habitual y normal. Y sin embargo hemos encontrado comunidades ricas, comunidades diversas, más incluso, muchos puntos, mucho más que en otros puntos de...
Que son así puentes, ¿no?
Sí, que zonas que están más expuestas, cercanas a esta, relativamente cercanas. ¿Cuáles son los procesos que llevan a que exista una zona, que esta zona sea tan rica? Eso no lo sabemos.
No. Eso
Son las grandes preguntas que están surgiendo también
Eso no.
también de la navegación y que llevan a discusiones discusiones científicas.
Y ahora está apareciendo al pie de la pantalla. Es un animal que hace mucho, que no, ha aparecido varias veces en estos buceos. No sabemos exactamente lo que es. Va muy rápido y deja una nube de sedimento
Would
tan...
work for you guys. I'd like to turn the ship 180 just so we can protect the umbilical.
ROV copies. Which way are you going to spin?
To starboard.
Roger. Okay. Whenever you like, we're just going to follow you.
Great, thank you.
Copy.
Copy.
So we're going to have to wind up moving the ROV. They're going to have to spin the boat 180 degrees. So we're going to
Okay.
come off and kind of follow around behind them like that, staying outside of our red zone.
Okay.
And
Yeah.
then once he finishes up, then we'll be able to keep up, and he'll just lead us.
Right, what does it mean?
That means we're going to stop the transect right
Yeah.
now as he's spinning the
Just
boat.
stop.
We're just going to stop,
Okay.
and we're
Yeah.
just going to follow around, and we'll come right back to here.
Basically
and
following,
continue on.
yeah, okay. All right.
We can explore off to the east and the south as the ship spins. You know,
Mhm.
we're just gonna follow them around like that, and then go like that.
Right, great.
No, there was a thing that slide from above and then
You're trying to tell me and then
Wait.
move right across the bottom.
That's the thing that was moving and then,
that thing was
Crashed.
sliding down. Yeah.
oh,
No, because the other day we saw something.
yeah, that's right.
Yeah,
Yeah,
I thought it was
I
the
was
same.
following, but yeah, I know what you mean. We followed from the meeting room, was on the screens, and we were wondering what it was.
It's true.
Yeah, I believe that. I saw it. I'm a witness.
Alright, so I'm gonna start face base. See what we find.
Yeah, just kind of explore that way, you know, as you start spinning, just follow the circumference of the red circle.
Bueno, y ahora lo que está pasando es, como decía Cristian, bueno, hay bastante hielo en superficie. No tenemos la plataforma de hielo, pero sigue habiendo restos de iceberg, sigue habiendo esos grandes pedazos de hielo que a veces impiden o dificultan la navegación del navío. Y como el navío y el vehículo SuBastian tienen que más o menos seguir una trayectoria paralela muy cerca uno del otro, si el navío se tiene que mover, SuBastian también. Entonces en este momento estamos un poco viéndonos forzados a seguir la trayectoria del navío mientras se intenta esquivar un iceberg. Podéis ver en la pantalla arriba que estamos completamente rodeados.
Y bueno, hay que destacar que una zona de bastante dinamismo de iceberg. Esta zona del mar de Bellhausen hacia el mar de Sediment. Y producto del mismo hemos encontrado esta ruptura de la plataforma. Hay que destacar igual que la plataforma, como lo dije en la sesión anterior, es la octava más grande de Antarctica, Ice Shelf, la octava más grande. La más grande obviamente son la de Ross, la de Narsen. Y ahí hacia abajo hasta llegar a George Clinton, que nosotros estamos justo en la parte sur de George Clinton, entre la isla Alejandro y la isla Spatz, que es un rincón inferior, digamos, del mar de Bellhausen, en la base de la península. Se puede ver en la pantalla la enorme cantidad de iceberg, algunos pequeños, pero como saben, pueden saber que los se vean pequeños son grandes hacia abajo. Se ven la misma parte.
Los pocos minutos que llevamos de inmersión en este fondo sedimentario, lo que sí hay zonas en las que realmente la densidad de holoturia es muy alta. Holoturia, pepinos de mar, se llama en español, es muy alta. Y una cosa que sabemos que donde la densidad de loturia es alta, quiere decir que la calidad y la cantidad de alimento también es alta. Y teniendo en cuenta que estamos a varios kilómetros de lo que era el borde de la plataforma de hielo hace unos días, es bastante llamativo que haya que este indicador de que existe tanto alimento, que son las loturia, esté presente. Quiere decir que de alguna forma ese alimento ha estado llegando.
Still going?
Yeah, he's still going. He's still turning this way.
ROV bridge.
Go for ROV.
Yeah, that's on our new heading. That should make things less stressful up here. You can relocate the ship's waypoint if you like.
Updated waypoint.
Thank you.
Oh. Aquí also.
Bueno, seguimos pendientes de lo que mande el hielo, y mientras tanto os voy a contar que esta expedición es una expedición multidisciplinar,
It's going to be half a turn.
como decíamos, liderada por la Universidad de Aveiro y el London University College. Y se enmarca dentro de la iniciativa Challenger 150 o Challenger 150, que es una iniciativa que forma parte de la década de los océanos de las Naciones Unidas. Está apoyada por ella y lo que pretende, o sea, es ser un esfuerzo coordinado entre
0.6, Roger.
un esfuerzo coordinado de científicos y sobre todo biólogos y ecólogos que trabajamos en mar profundo, con la intención de rellenar los vacíos de conocimiento que existen sobre, valga la redundancia, el mar profundo a nivel global. Nos dividimos en diferentes grupos de trabajo para cubrir las diferentes zonas del océano profundo. Y una de las iniciativas, una de las ideas de forma coordinarnos para una de las cosas, pedir proyectos o organizar, idear y organizar expediciones como esta. En el mismo marco, este año pasado, en 2024, hemos tenido varias expediciones a bordo del Falcon Tour, en el sur de Chile. Hemos conseguido uno de los objetivos, que era mapear zonas cuya topografía es desconocida, así descubriendo y describiendo zonas que se encontraban borrosas en los mapas por primera vez.
Bridge, ROV, updated waypoint, please.
Updated waypoint.
Descubriendo montes submarinos, describiendo su biodiversidad, también zonas de fuentes frías y cañones submarinos. Y ahora nos estamos aventurando hasta la Antártica. Esta expedición, efectivamente, como decíamos, está siendo bastante desafiante. Debido a que efectivamente estamos haciendo lo posible por llegar a los lugares más inaccesibles. Eso, por lo tanto, tiene un precio, y es que a veces, pues efectivamente, el hielo no nos deja trabajar como nos gustaría. Pero al mismo tiempo también está siendo muy, muy gratificante. Realmente los ecosistemas que hemos descubierto en sitios que no nos esperábamos están siendo realmente fascinantes y nos van a ayudar a entender mucho mejor cómo funciona el mar profundo, cómo funcionan los ecosistemas antárticos y, por tanto, cómo funciona la vida en nuestro planeta.
cuenta de lo que comentaba hace un rato de la calidad del sedimento, como cambia de un momento a otro, de una orientación a otra, dentro de la topografía del relieve del lecho marino, En este caso se observan noloturías irregulares de dos especies. Y algunos erizos, el típico comportamiento de los erizos que se cubren con conchas de moluscos muertos, en este caso con conchas de ostiones, scallops antárticos.
para camuflarse. Nuevamente volvemos a ver ese draco de aletas pélvicas largas. Que no, Draco creo que era el apellido. Perdón, el apellido. El nombre genérico. Que no, Draco wilsoni o wiltoni. Bueno, lo que se observa arriba de la pantalla en la esquina superior derecha son los puntos marcados que tiene del track, digamos, de la ruta que tiene que hacer el vehículo. Y como pueden ver, nos dirigimos ahora hacia el punto número 3, Waypoint 3, para establecer para seguir avanzando en nuestra ruta. Y recuerden también que estábamos como con un desvío del camino producto de los icebergs de la superficie que estaban acercándose al buque.
So it looks fun. So we're gonna go with it. So it's gonna be reading. Okay. So cut across the track.
Hola. Hola, everybody. Hola. ¿Qué tal?
Justo está uno de los pilotos del ROV saludándolo. Por eso ese revuelo en la sala.
Gifts from the scientists. You ready to pick up some rocks for us? Pick some rocks first? Before? After my candy. Yeah, everything waits for the candy.
Decir que los pilotos en este vehículo son absolutamente fantásticos, una vida fuera de lo común. También un irrefrenable apetito por el chocolate. Chocolate caramelo de parte de acaban de cambiar el camino del turno. Ellos cambian aproximadamente cada 2 horas. Entonces hacen unas horas para muestrear animales frágiles, animales rápidos, animales interesantes. Y estamos ahora en medio de un cambio de guardia. Antes de empezar su guardia están comiendo y repartiendo chocolate entre los presentes. Y ahora sí, vemos perfectamente el fondo. Ahí viene mi cordal, una botella. I'm not sure. Sasha?
Sasha, you want rock?
Sasha?
Of course I do want to rock. Can you rock?
Preferably not the surgeon, but actual rock.
You want that rock?
Yeah, let's take that rock.
Les voy a pasar con Sancho, que va a dar alguna relato sobre la roca que estamos mirando.
I would not mind at all.
Introduce myself? Yeah. Hello. Oh. Yeah. Hi everyone. My name is Sasha Montella. I'm a co-chief scientist of this cruise with the Bellingshausen Sea. The reason why we are interested in rocks here is because Antarctic continent is largely covered by very thick ice sheet, and so we know very little about actual geological evolution and the history of this region. And ironically enough, this expedition allows us to provide fairly comprehensive geological mapping from the submarine record. Typically we do it in terrestrial environments where the classical geologists would go to the mountains, pick rocks and reconstruct the evolution of certain area based on what they see. But because Antarctica is in most places virtually impossible, it's this particular expedition that allows us to attempt something like that, but in submarine setting. So we're trying to regularly collect rocks at regular intervals, and that gives us some understanding of the types of geology we encounter here, and hopefully to reconstruct evolution over this area on very long geological timescale. This is also quite important because the bedrock or the surface beneath the ice actually plays a very important role in regulating the flow of ice itself, and therefore the dynamics of ice sheet and how it may behave in the future and how it may contribute to sea level rise. So everything is intertwined here in this expedition. We work on multiple timescales, from millions of years to thousands of years when we talk about glacial geomorphology, finally to days when we talk about processes related to the oceans and biological processes. This is a good rock. I haven't seen a rock of this color before during this cruise, although it can be quite difficult sometimes to actually tell what kind of type of rock it is because it's weathered on the surface. So once it is back on board on deck, we will be able to split it and see what the fresh cut looks like and what kind of type of rock it is. So yeah, that's a great question on why we encounter these individual chunks of rock in the middle of fine sediment and the surface, and the reason for that is in most cases the glaciers. So glaciers that drain large ice sheet are very erosive agents that carry bits and pieces of rocks that they erode on their way. Rocks can be entrained in glaciers from the surface, so-called superglacial debris. They can also be eroded on the way at the base of ice, so-called subglacial debris. And then as ice flows, it carries these rocks and the little bits and pieces with them, and then ultimately it floats and melts, and where it melts, these drop stones, these rocks that it carried for long distances, then finally ends up somewhere in the middle of ocean, in the middle of fine sediment like this. So this is also very important for reconstructing so-called provenance of the study area. So these rocks that we find here don't necessarily originate in this very area, exactly because glaciers can flow for hundreds to thousands of kilometers, and so these rocks may originate from elsewhere. So the more of these drop stones and general rocks we pick, the fuller is the picture for our reconstructions. Yes, glacial erratic rocks, exactly that. Sometimes you can also see these rocks in the middle of fine sediment just because of the gravitational process. If you have very steep hills that are fairly unstable, then you can have gravitational process causing these small bits fall from cliffs and from steep slopes, and then end up on the relative flat bits that are generally covered by fine sediment. But in this area, we expect most of them actually occurring due to the melt out from ice that originally carried them. rocks origin. I mean, if they originally are superglacial origin, so if they get on the surface of the ice, then they indeed start melting through the ice, and then they carry. The question is about the sediment. Yes, they end up.
Yes, sir.
Buried into this in the sediment, but these particular rocks on the surface just indicate that they are of very recent origin, so they're very recent melt out from the ice shelves, likely. And remember that this area was occupied by thick ice shelf until a week ago, so no wonder why we see many of those on the seafloor. But indeed, if you drill a core, you will find often layers of these drop stones, these rocks dropped and lost by ice in the past. So it's not just the rocks on the surface that we see. If you take a look at the cross section, we will see many more layers of these drop stones, indicating past melt out of debris from glaciers in the past. In terms of the finding signs of tropical lands from long ago, that's indeed a good point, because we actually colleagues drilled through the ice into the bedrock underneath the ice in Antarctica 2 or 3 years ago. There was paper coming out in Nature, and what they found, what they found underneath the ice in the bedrock was the signs of the roots of the tropical rainforest of Cenozoic of about 60 or so million years ago, which is indeed quite fascinating. If you think about it, that underneath the ice there are rocks that are indicative of presence of completely different climate in the past, much warmer than we are in now.
Like that. No, we are where the hand is. So then the next week we are down here.
Bueno, nuevamente observamos, volviendo a la parte biológica después de la explicación detallada que ha dado Sacha sobre las rocas y los procesos geológicos que acarrean las rocas hacia esta parte del lecho marino. Vemos que hay una gran abundancia en este momento de equinodermos, ¿ya? Específicamente de pepinos de mar, ¿ya? Lo cual, como dije anteriormente, dan cuenta del tipo de sedimento y de la materia orgánica que puede haber para que ellos estén alimentándose. Son animales que se alimentan de materia orgánica directamente de los sedimentos, ¿ya? Y se observan dos especies claramente, una con prolongaciones, por llamarlo así, más larga, y otra más corta, ¿ya? Una probablemente del género Protelpidia o equivalente a Scotoplanes en otras latitudes, y también uno muy similar, que prolongaciones más cortas, que es del género Ledmogone o Periagone, ¿ya? También muy abundante, que justo se están viendo ahora muchos de ellos en este momento. Ketognatos, que son que acaba de pasar uno por la pantalla. Un nemertino gigante ahí al lado de la piedra. Y bastante también scallops, que son vieiras o ostiones, bivalvos. Que hay que destacar que es la única especie de bivalvo de esta familia, de este tamaño, que habita en la Antártica, que tiene bastante conexión con la especie sudamericana. Justo en este momento estamos viendo un pulpo, octopus.
Hemos visto muchos pulpos de
Sí,
esta especie en esta campaña.
concretamente hemos visto bastante de la misma especie, creo yo. Ya, y que también tienen en común que han mostrado este comportamiento bastante pasivo, ¿no? No se han visto moverse en realidad.
Normalmente muy tranquilo.
Muy tranquilo. Maravillosa la vista, el primer plano, y detrás un erizo.
Los erizos, como decíamos en otro buceo de esta campaña, les gusta taparse con otras especies, con conchas. No sé muy bien lo que tiene.
Tiene, parece, algunas escamas de élitros de poliquetos, parece.
Ah, fíjate.
Sí.
Y otro erizo más pequeño.
Y otro erizo más pequeño. Correcto. Puede ser la especie Cirroctopus o similar. Magnífica vista de este pulpo con sus ojos cerrados. Está claramente descansando.
Estos pulpos no parece molestarle nuestra presencia en absoluto.
Claramente.
Siempre lo encontramos durmiendo y durmiendo se quedan. Eso era uno de los buceos que estaban como en medio de lo que estábamos colectando, que lo empujamos un poco para que saliera de plano y no, ahí se quedó.
Ahí abajo pasó fugazmente al lado de la piedra, por la imagen, un erizo sidaris, el grupo de los sidáridos, que son de muy largas púas.
All these rocks that probably dropped out by the glacier.
Yes, melt out. There
There are no walls.
yeah, unless there was, it's usually melt out from ice shelf in this area.
Esta estrella
Es una fibra.
de gran tamaño. Realmente hay muchísima densidad. Y esta loturia realmente parece también estar muy tranquila. Esta es una especie de loturia que hay que decir que tiene capacidad de nadar y
Sí.
tiene una natación muy elegante. Es casi hipnótico ver una de estas loturias nadando. Y sin embargo no parece que le moleste en absoluto la presencia del vehículo. Incluso hemos estado en otras inmersiones capturando algunas, obviamente con fines científicos. Y las que hemos capturado tampoco parecían huir ni oponerse demasiado a lo que estábamos haciendo, por tanto parece bastante interesante. Zoom into this side. Yeah, also doesn't seem too active. Oh,
Se pensó enganchar el tenófilo en el tubo y lamentablemente vimos un desenlace fatal.
Bueno, eso parece ser un proceso natural, incluso frecuente, porque hemos visto mucho. Aquí estamos viendo.
Ahí estamos viendo lo de la natación que comentaba recién. Del Atmogoni.
Bueno, eso, aquel animal de ese color tan llamativo, como violeta, rosado y violeta, parece que se chocó en su camino contra un poliqueto,
un tubo de
poliqueto y fue. Y se lo destrozó completamente.
Eso también da cuenta de la fragilidad de muchos de estos animales.
Es curioso porque hemos visto varias veces en buceos anteriores como masas rosadas en el fondo del mar y todavía no sabíamos bien lo que era. Yo creo que muchas pueden ser este tipo de procesos.
Sí. Son como gusanos gigantes que se ven, son enteroneusto, un tipo de hemicordado. Esto aquí me refresca la memoria. Y aquí también ha sido bastante frecuente en los buceos que hemos tenido.
I was actually thinking of asking, at least at the end of the wall, we could do that. Because we are suspecting that because of the current, it should be a good one to look at.
Ahora a continuación les paso para que relate alguna experiencia y algunos comentarios respecto al buceo y a lo que es la campaña a Leslie Novoa, de asistente de investigación de la carrera de Biología Marina de la Universidad de Magallanes, para que relate, que ella también está en este turno en este momento.
Hola, mi nombre es Leslie. Les voy a comentar un poco mientras se dispersa el sedimento, ya que es demasiado fino y se suspende con facilidad. El robot submarino que nos ayuda en los muestreos tiene el nombre de SuBastian, pero no se llama así por cualquier cosa, ya que el barco se llama Falcor y estos nombres están inspirados en la película de La historia sin fin. Falcor es el nombre del dragón de la suerte, quien ayuda al protagonista de la historia, que es Atreus, a encontrarse con Bastián y que entierre al mundo de fantasía, para poder así ayudar a rescatarlo, tal cual está haciendo en este momento con nosotros, llevándonos a este mundo submarino. Nos encontramos a una profundidad de 797 metros y a una temperatura de 1.18 grados Celsius, parámetros que no son aptos para ningún ser humano. De no ser posible, o sea, de no contar con SuBastian, no podríamos estar aquí visualizando los fondos marinos que hemos visto durante los buceos de los últimos días y los que ha realizado en campañas anteriores. Todas estas criaturas particulares que podemos observar están acondicionadas y están adaptadas a todas estas condiciones agrestes y rudimentarias. Cabe recordar además de que esta zona está debajo de una plataforma de hielo que se movió hace poco tiempo. Por lo tanto, muchos de estos organismos nunca han visto la luz del sol. Además, es una zona donde el hombre nunca ha posado sus ojos, por lo que al mismo tiempo que nosotros estamos descubriendo esta área a través de las pantallas, ustedes están haciendo lo mismo de la pantalla de su computador, de su tablet, de su celular o de la televisión de su hogar. Sobre el sedimento se puede ver que hay una gran cantidad de pepinos de mar, llamados comúnmente como sea pigs. Estos se orientan en el sentido que va la corriente marina para alimentarse del sedimento. Y a su alrededor se observan unas pequeñas conchitas que son scallops. También en la pantalla pueden ver 2 puntos de color verde. Estos nos entregan una escala de más o menos cuánto miden estos animales. La distancia que hay entre estos puntos son 10 centímetros. En pantalla pueden ver en este momento una medusa que está atravesando. Qué bellas formas, qué bellos colores.
Okay, Bridge, using the mode, please.
Resuming the move.
There was a question about do glaciers carve valleys in submarine environments as they do on land, and the answer is absolutely yes. And large ice sheets like Antarctica and Greenland ice sheets actually erode very large valleys that are much larger than fjords. They're called cross-shelf troughs. They could reach dimensions of hundreds of kilometers wide, hundreds of meters deep, and span across the entire continental shelf, across continental shelf, so depending on the width of the continental shelf. Past ice sheets like Eurasian ice sheet in the Barents Sea, for example, there is so-called Bear Island cross-shelf trough, which is roughly the size of France. So yes, because ice sheets are drained through these fast-flowing glaciers and ice streams, which are much more erosive than surrounding ice, you can see these patterns of elongated depression radiating across continental shelf from the margins of the former and present-day ice sheets. And you can see these features even on fairly large-scale topographic bathymetric maps of the global ocean. So if you open, for example, Kepco map or physiographic map of the global ocean, you will be able to see this large valleys eroding and cut into the seafloor in high latitudes and in mid-latitudes as well.
Bueno, hay que destacar que en esta hora que llevamos nuestro turno, en el cual está Patricia Esquete de la Universidad de Aveiro, que es la Scientist Lead del crucero, la líder científico del crucero. También está Sacha Montelli, que es el co-líder del crucero, quien habla, que es Cristian Aldea, y también está Leslie Novoa, ambos dos de la Universidad de Magallanes, Punta Arenas, Chile. ¿Ya? Y ha sido un buceo, no siempre es espectacular esto, no, igual está bien que se vean este tipo de fondo un poco más, entre comillas, sin tanta fauna
Como
espectacular.
homogéneo, digamos.
Como homogéneo, porque son estos grandes depósitos o bancos de sedimento. Entonces, también da cuenta de las condiciones sedimentarias en que ha estado sometido esta porción del lecho marino bajo el hielo de la plataforma George V. ¿Ya?
También hay que decir que los fondos sedimentarios son homogéneos a la vista.
Claro.
Sabemos que existen esos animales que viven enterrados en el sedimento de una clase de tamaño mucho más pequeña.
No visibles a los humanos.
No visibles a los humanos y que además están enterrados. Y todos esos animales dependen mucho más de las condiciones del sedimento a pequeña escala. Eso quiere decir que donde hay una acumulación de materia orgánica por cualquier motivo, porque hay un pez muerto o porque hay una loturia haciendo su actividad, puede haber y cambian un poco las condiciones de sedimento, de nutrientes, de carbón, o porque está más oxigenada, porque ha habido un movimiento de otro animal, cambian las condiciones a pequeña escala y por lo tanto puede haber acumulación de biomasa o biodiversidad de esta clase de tamaño, que simplemente no visible al ojo humano. Y cuando tenemos fondos rocosos es mucho más fácil de apreciar cuando la biomasa es mayor y cuando menor, y la biodiversidad que hay en esta clase de tamaño más pequeña es más complicado. O sea, en estos fondos sedimentarios es más complicado porque la gran parte de las especies no son visibles.
Bueno, eso también lo observamos nosotros, la fauna a pequeña escala, que también se conoce en términos biológicos como meiofauna, la podemos estudiar gracias a los testigos, ¿ya? O núcleos que se llaman push core en este caso, porque se clavan en el fondo marino gracias a la acción del vehículo, ¿ya? Y obviamente buscamos un punto preciso para tomar esos push core. Observamos dos fibras de muy gran tamaño. El disco central debe medir por lo menos 8 o 10 centímetros. Acaban de pasar.
Sí, aquí está claro que alimento no falta.
No, y eso también se puede observar por las huellas que se ven en el fondo, que dan cuenta del tráfico que tienen en la ola o loturia, los erizos, estrellas.
En realidad es una zona de gran actividad.
Sí.
Hay que decir que a grandes profundidades y cuanto más profundo nos encontramos, el ritmo de la vida es mucho más lento. Cuando decimos el ritmo de la vida estamos hablando de todos los procesos biológicos, empezando por el movimiento individual de cada especie, las tasas de crecimiento,
la longevidad,
la fisiología, exactamente. Esto es porque la cantidad, entre otras cosas, porque la cantidad de alimento que llega es cada vez menor. Entonces, todos los elementos del ecosistema tienden al ahorro de energía. Y por tanto va todo mucho más despacio. El ahorro y la acumulación de energía. Entonces esto va mucho más despacio. Los animales crecen más despacio y tienden a ser mucho más longevos. Por eso encontramos, por ejemplo, esponjas de gran tamaño. Crecen muy despacio y aún así llegan a tamaños colosales. Estamos ahora lo que venimos haciendo hace un rato es una parte de este viaje que consiste en hacer lo que llamamos transectos de fauna. Y lo que hacemos es hacer filmación casi sin recolectar nada, sin acercarnos demasiado a si es necesario, siempre podemos hacer un pequeño zoom o ver un poco más el detalle, pero reduciendo esas acciones al mínimo, porque después estos vídeos los analizan nuestras compañeras de la Universidad de Aveiro y les sirve para hacer estimativas de densidad y de biomasa. Digamos de cuántos animales y cuánta biomasa por unidad de superficie se pueden encontrar. Entonces para eso necesitan estos transectos de vídeo continuo. Y luego lo podrán comparar con otras zonas de las que hemos estado estudiando y en las que vamos a seguir estudiando. Y hacer comparativas entre zonas donde existe mayor biomasa, mayor densidad de individuos en general y de cada especie. También estimativas de biodiversidad. Ahora parece que andamos hacia atrás porque estamos en una cuesta abajo. Entonces lo que han hecho los pilotos es girar el vehículo para que a pesar de ir cuesta abajo consigamos ver esta pared o esta pendiente. Es realmente una maniobra y una forma de avanzar bastante más complicada, pero tenemos la suerte de contar con pilotos, como decía, magníficos y con una habilidad extraordinaria.
Claro, en cierto modo vamos retrocediendo, ¿no?, con el vehículo. Van avanzando hacia atrás y de esa manera también se puede ver claramente lo que hay cuesta abajo.
Una persona preguntando por qué, bueno, tiene un montón de preguntas sobre los erizos de mar. En primer lugar, ¿por qué se ponen conchitas encima? ¿Por qué llevan sombrero? Yo honestamente no lo sé. Cristian, ¿tú sabes por qué?
Hay son hipótesis que para camuflarse. De hecho, muchos erizos, especies de erizos intermareales también de la costa también lo hacen, al menos en Magallanes. Erizos que en cierto modo igual están relacionados con esta especie de acá que parece ser Esterequinus o alguna similar, y también hacen lo mismo y a veces se ponen piedras, no de gran tamaño para que no lo aplasten, pero piedras que ellos puedan levantar con sus púas y pies ambulacrales, las van levantando y se las van poniendo.
Esto se observa en muchos sitios, también incluso en el Mediterráneo, en todo tipo de profundidades. Muchas especies relacionadas y otras no relacionadas con esta se ponen esas conchas encima, pero nunca yo personalmente nunca supe por qué tampoco.
Probablemente pueda estar documentado en algún trabajo científico de etología, que es el comportamiento, la ciencia que estudia el comportamiento animal. Podemos buscarlo.
Esa persona también tiene un buen punto, y es si los erizos no tienen un cerebro, ¿cómo que pueden entender lo que están haciendo? ¿Cómo pueden entender si está poniendo un sombrero y para qué ponerse y no ponérselo? Probablemente es un comportamiento que no lo piensan. comportamiento
Es
heredado, los
innato.
comportamientos se heredan también.
Geological downslope.
It's probably us,
Caused by a bomb or something?
not caused by the vehicle, I think. Yeah, it was us. Did we do that?
Is it a slow process?
No.
Yeah. So you can follow trees correctly. It's really cool. Yeah, you see how it evolves. This is another. This could be of interest. Sediment holes. Some rocks. This is really cool. Yes, that would be great.
Yeah, if we zoom out a
Take a
little
piece
bit.
out, it would be great.
Anything loose in there?
Not a huge one, just like fist size would be great.
We can zoom out a little bit. How do you know?
Yeah, it's how much you said, basically.
Let's see that.
Look at this. You can see this phenomenon often on the cliffs. There's the cure often it starts the process and avalanche sediment.
Sediment?
And things the clouds that you see.
No, that's from us.
Is it from us?
Yeah. It's when it's upflow when we're sucking it in.
But you see it frequently when you go. Okay.
It's flying backwards.
Yeah.
When he's flying forward like that, it's back this way.
Yeah.
Can you just zoom into it?
Or the animal.
Yeah. Maybe this rock. Maybe this rock is doable.
Possibly. Yeah. We can try to go over
Yeah, frontier rock. Yeah, that's the one I pointed out.
Great.
We are synchronized.
Yeah.
It works
Rock
nicely.
rock finders.
Looks like fist size, right? Fist size is fine.
Well, it's a little bit bigger than fish size. It's a big fist.
Yeah, because they're better than a hop up a little bit more. You should be alright.
Let's stay there for a second. Moving around quickly. Sorry, moving around. It's good.
It's a snowstorm overrun. And we hope to get it back to the cave dated and figure out how old this formation is like to construct a geological ocean there.
I told Andres I didn't tell you we have a rock salt. If you need rock salt.
He just
Oh, you made that?
That's the one.
Yeah, I kind of wonder. When you say fist size, is a human fist or is SOBastian fist?
That's a good question. Gorilla fist.
Bueno, justo estamos viendo el muestreo en vivo de
Whose fist?
de un trozo de roca submarina.
That should be standardized is SOBastian fist.
That should be it, yeah.
The one and only.
That's the only
Hay
fist
bastante
size.
revuelo también por el tipo de roca que está extrayendo, porque para los geólogos que andan a bordo es impresionante descubrir este tipo de roca que ha estado por millones de años bajo o en este lecho marino y miles de años probablemente cubierto por la misma plataforma de hielo George V. Oh, y vemos que falló el muestreo, se fue hacia abajo.
But we're
Seguramente
going down anyway. We'll refine
estamos
it.
juntos en una pequeña pared,
We're on a cliff face, so.
ya, pero puede ser que haga otro intento.
It might just be down here.
Yeah. So before that, can we zoom in here? Just zoom in. See if it's a funnel. I think it's a
This is a bryozoan.
dead one. It's a bryozoan, yeah.
It's a bryozoan.
Not interested.
It's a bryozoan and a bunch of dead polyps.
Ya. Bueno, también hay conversación aquí de fondo porque justo hay un trozo de roca de los que se han muestreado y se puede ver que es metamórfica. Bueno, los geólogos ya la han identificado, así que eso también da cuenta de la importancia de esta expedición, porque no solo consiste en investigar la biodiversidad, sino que primero que todo cartografiar o mapear el fondo marino ya a una resolución altísima, ya que es capaz este barco con un sistema que se llama multi-hash de tener una imagen virtual, de generar una imagen virtual en alta resolución de la topografía submarina. Por tanto, asociado a eso también va el estudio de los tipos de sedimento, rocas, del tipo de lecho marino que tienen estos fondos marinos. Y aparte, asociado a eso también está el estudio de lo que es la biodiversidad de estos fondos marinos, en la cual personalmente también estamos, o personal y grupalmente con el grupo de investigadores estamos también asumiendo, y asociado a ello también va el estudio de la ecología trófica o las relaciones tróficas, quién se come a quién dentro de este ecosistema, ¿ya? Y múltiples estudios más también oceanográficos, ¿ya? Para ver cómo las corrientes atraen o transportan, más bien dicho, nutrientes a estos fondos marinos que han estado cubiertos de hielo por miles de años hasta prácticamente ayer o pocos días atrás. Por tanto, es importantísimo integrar toda esta información en este rincón del mar de Bellihausen, que no es majadero decirlo, pero no había sido explorado de esta manera. ¿Ya? Hay que destacar también que el mar de Bellingshausen es una porción marina del océano Antártico, del océano austral, que es uno de los menos estudiados a lo largo de la historia, junto con el mar de Amundsen, que es el mar vecino hacia la zona más occidental. Por tanto, es importantísimo este tipo de estudio que se está realizando. ¿Ya?
Small one? What do you think, man? Small one, the big one?
Fist? I don't know.
The fist size.
What's been in this one? The fist
Yeah.
size one.
Oh, the big one.
Yeah, the big one. Totally doable, guys. Totally.
You don't want the small one, right? It's okay. You want the bigger one, the one on top.
Whatever you can do.
I think that, obviously,
Whatever you feel more comfortable with.
I don't know if the big one is enough. You should find out. Just don't knock the little one off, you got the big one.
Well, I could pick the little one off first, then we'll take the big one. How's that
Alright.
sound? That sound good?
That sounds strategic.
Yes, sounds great.
Vamos a ver que el brazo de SuBastian va a ser un segundo intento de muestreo de una roca submarina.
A what? A
El-
grilled cheese?
Una roca aproximadamente
Oh, yeah.
de 15 centímetros a 20 centímetros de diámetro.
That might not be loose either.
Hay que destacar que este muestreo, este brazo se manipula desde aquí de la sala de control a través de piloto y asistente, y un piloto
Well, that's the whole one.
realiza lo que es
Actually,
el,
Are they separate, do you think?
Yeah.
I think they're separate, but I think if we grab the first one, the other one will follow.
Yeah.
Will fall.
realiza lo que es
You want this one?
el desplazamiento del
So we
vehículo,
can try the tall one.
y otro piloto manipula los brazos del robot y las demás estructuras a través de un sistema de palanca, digamos, de tipo
This is a very
joystick,
good rock.
lo cual requiere bastante precisión para el manejo y la extracción de muestras.
Is that a prize? I'll check the grab this thing.
Yeah, that's great.
No, is there a prize?
Price? I will cut your face out of this rock.
We have a bonus with the stone, please.
And if you don't get it, we'll correct your face with the rock.
Yeah.
I know.
Otherwise,
It will be like
wood chocolate will work as well.
Michelangelo kind of sculpture.
Wait.
Go wrong.
Might be slightly larger than fist teeth.
Oh.
We want a bonus with the stone.
I'll try from the backside. Can you, science? I'm afraid it might fall off.
Yeah, the little ones should be grabbable or as well.
So this I can take in my book.
It's very difficult to catch because it's too
Too
big.
Yeah. If it's too difficult, you could go with the bottom one as well. This one seems a bit thick, right?
I'll give it one more shot.
It's like trying to eat triple cheeseburger in one go.
Yeah. It doesn't look too easy.
Bueno, la resuspensión del sedimento también hace más difícil el que el brazo pueda tomar con precisión, o más bien que el piloto pueda ver con precisión lo que el brazo tiene que tomar.
I thought smoking was prohibited in the ocean.
Breaking the rules today. Is that
I
right?
wanna flip it over.
Which would you?
You're talking about this one, the small one.
Yeah, that'll be fun.
Okay, we'll try this one.
Porque va a tratar de intentar tomar una menor.
Just on the edge of it. Sit. Use on. dust then.
Wait.
Is it still there?
Yeah, I saw something.
It's still on that.
It's fine. Deep there. Just under it. And a little deeper. That should be close. Nope. They got some sediment though. Yeah. Maybe if you dump that off to the side, because I think when you're coming in, all the sediment's coming off to us. This stuff is crazy. I think if you had it top down, that wouldn't stir up so much.
It's too wide on top. Yeah, on the side. Or you put this porch out and I'll slide it on top. I've done that before.
Just slap it onto the board.
And forward book.
Seeing the drive.
Bueno, lo que se está haciendo es que se está esperando que el sedimento se disperse un poco y que aclare la visibilidad para ver si podemos seguir muestreando estas rocas.
So you want to sit too?
What about this one? As a plan B.
Importante también que se vea esto, que se muestre esto, porque también evidencia la dificultad que tiene de mostrar el fondo marino.
No idea.
Es extremadamente complejo,
What do I know?
requiere de mucha paciencia, dedicación y también por sobre todo la destreza de los pilotos del ROV.
Let's call it then.
Actually,
We'll let the other one clear up at the bottom, on top. And then,
Ahí vemos que vamos por un nuevo intento.
Yeah, the big one's on the edge, ready to fall off too. Which one are you going for? This one?
everything good? No crushing anything?
No, I don't think so. I think that's just part of the
it's probably
wall?
not part of the wall. No.
It's part of the main rock? Or?
Yeah, that's part of the wall.
Okay.
just wall.
It's impossible.
Yeah, but the
Okay,
old,
this one. Check it.
Alright.
small one is still there.
What do you need then? You need a little more zoom on the set?
Ahí, cuando se dispersó el sedimento queda otra roca descubierta que está suelta, digamos, que se puede ser muestreada más efectivamente. No, es muy difícil.
The most difficult rock ever.
That one could work. The big rock guy.
Lost. One more stab at this and then try to find a different one.
Yeah.
Yeah, there should be more.
That's just like a pillow setting. Come in. It's a little bit skinny on the end there.
Este intento va a ser bueno. Espero que sí. Seguro que sí.
Seems promising.
A esta altura estamos todos haciendo barra por el Subastian hasta que pueda marchar. Y finalmente se pudo.
Small graph for SOI Antarctica Geological.
Hasta una pequeña medusa vino a observar el muestreo y al hacerle zoom a la roca se ven lo interesante para uno como biólogo, que también tiene fauna asociada encima, tubos de poliquetos y espero que otros organismos más. Que hay que destacar que nosotros como biólogos siempre revisamos las rocas apenas llegan a cubierta y hacemos un análisis de la fauna que hay sobre las rocas también.
Y siempre encontramos cositas.
Y siempre encontramos y hemos encontrado muy buenos hallazgos, aunque no lo crean, de pequeños animales que viven sobre las rocas.
Which box would you like it? Outside or inside?
We can put it in. Let's put in the second one.
Inside.
Outside, inside.
Inside.
Outside.
Inside. What's coming out, man?
Prospective.
Alright, that is the camera. That is the porch out. This is the sit coming down. Is it basket one?
It's basket 2. Basket 2.
Basket two, thank you.
For no reason, it's more like similar to that.
Bombs? Right. Don't let us down, gravity.
Oh, what?
Is this road basket 1 or 2? I mean, is it this one or this one?
This one.
Yeah.
Porch coming in. Alright, there's the porch in. Okay,
Okay.
down the mountain,
Down the hill. Oh, down the mountain.
whichever.
Whatever. Down the
Slope.
canyon. Down the
Chasm.
channel.
Bueno, despegamos del sitio y continuamos avanzando
Right after we'll be going up.
a través del cañón hacia abajo. Vamos a seguir retrocediendo porque vamos por una ladera cuesta abajo.
Después cuando subamos hacia arriba iremos por la cara opuesta.
Que seguramente tendrá otro tipo de fauna, porque como hemos visto la configuración o las comunidades dependen mucho de la orientación a pequeña escala.
Another drop off.
And it's a great experience. Let's have a look at this little piece of wall.
Alright.
Just sort of look. I mean, we're probably not going to collect anything, but just zooming in so that we can estimate what is living there.
Tenemos bastante briozoa en la parte, en la cara inferior de esta roca. Algunas esponjas arriba también. Brachiópodos. Brachiopods, bryozoans, sponges. Some shrimps, que son pequeños camarones de crustáceos decápodos. Hay que destacar también que los crustáceos decápodos, que son camarones, gambas, cangrejos, no son muy abundantes, muy diversos, más bien dicho, en Antártica. Vamos a hacer zoom ahora en una colonia de briozoos que frecuentemente tienen asociados pequeños crustáceos sobre su superficie. Epimeria, así, anfípodo del tipo epimeridos. Hay que destacar que la colonia tiene aproximadamente 10 centímetros de ancho. Ahí viene uno de los camarones.
Yeah, it's a kind of type of animal we've been seeing before. This is Ketognas here, arrowworms down here.
Está explicando Patricia que son los pequeñitos blancos son ketognatos.
It's actually fine. I think we've seen what we needed.
¿Spider?
Yeah, we can continue.
¿Se puede ver los up?
It's a nice density of shrimp in here. Seems that we keep seeing the same type of shrimp.
Estamos descendiendo una ladera, así que van a ver que la profundidad cada vez empieza a aumentar más. Estamos metiéndose un pequeño cañón hacia el siguiente waypoint. Journey down the hill, but then we'll be up in here.
Right after.
Looks like they came out with explosion. Yeah, it's still pretty stable.
Yeah.
It's cloud though. So you can actually see something.
Yeah, it's fine. We have to drop a little bit. It's okay. Totally fine.
Is it? All dust and kicked up. It's just water falling down. Yeah, it's black around. Seafloor again. It's fine. Around. Good. Sure.
Volvemos al campo de las oroturis, parece.
All right. Another 200 meters.
And the rock.
Another rock. Oh.
You find on the rock.
It's deeper again, huh? I think this is the way to open instead of just facing straight into it. Yeah. Use the lab. Maybe it'll do less just blasting. Strong one, strong one.
Are we racing against the rock?
Con una verdadera carrera contra esa roca. Eso que hay allí puede ser una oroturia. Y ahí se puede ver en pantalla en la parte superior cómo el vehículo va descendiendo del punto 4 al punto 5. Ya aumentando la profundidad, obviamente estamos a 863 metros ya casi de profundidad.
5 will be going down the hill.
Or at 5 we go down the hill.
Huh?
Instead of 5 we go down the hill.
No, all the way to 5. I think 5 is the bottom.
Cool.
If I'm not wrong.
Y evidentemente hacer un cañón con los bordes sedimentarios es más bien poca la fauna que se ve, algunos erizos o fiuras, perdón, holoturias.
My map is totally different.
Scallops. Poliquetos tubícolas. Ahí se puede ver los erizos que estaban con una mancha roja, probablemente lo que acabamos de ver hace un rato atrás. Probablemente son tenóforos que chocan con ellos y quedan esas marcas rojas.
So is it about 45 degrees here? No. Slow.
See if we can eventually, after we go down, have a look to this guy.
Yep.
Y llegamos a la parte inferior ya, o muy abajo en la pendiente.
Not really what I thought it was.
De lo primero que se observan es algunas colonias de briozoos, braquiópodos.
Actually, still a close up. It's actually, I think it's a sea star.
Si se puede hacer un close-up en el...
It's a sea star we haven't seen yet.
Bridge updated position.
Data waypoint.
Yeah, we'll just let you know, we're just going small moves here. Forward here.
Say again?
Just to let you know, we're just making small moves here. It's going canyon over here.
Copy that. Thanks, Ben.
This is one of my friends. Can you focus on this one?
Una especie de equinodermo.
Oh, beautiful. Thank you.
Se pueden observar los pies ambulacrales.
Thank you for the ride.
So grateful. Thank you.
Magnífica la vista. Bueno, me despido. Acabamos de terminar nuestro turno y ahora viene el profesor Matthew Lee de la Universidad de los Lagos, el profesor Cristian Rodrigo de la Universidad Andrés Bello, Antonia Kaiser del Senckenberg Institute, Alemania, y el profesor Américo Montiel de la Universidad de Magallanes, Punta Arenas, Chile. Así que muchas gracias y nos veremos la próxima.
I should know.
Evening.
Spot so you guys can see something. We come down the wall.
Kicking up everything.
Yeah, every time you thrust backwards, it's up this way.
Yeah, I mean, the topography looks like it's quite a narrow trench. So.
Yeah. It's just a lot of down levels. Even more right now, it's about 7 meters. Okay. Get back.
Good evening, everyone. It's 10 o'clock local time. We are diving under what used to be the King George VI ice shelf. Another dive, this time again we're starting deep and going up shallow, but at the moment we seem to be in the middle of a small trench, going down and then we'll be going straight back up again. My name is Dr. Matthew Lee. I'm an investigator at the Centro IMA, Universidad de los Lagos in Puerto Montt. I'm here with my colleagues Americo Montiel from the University of Magallanes and Christian Aldea, also from the University of Magallanes. We work with Dr. Geological Soto, the University of Valparaiso. And also on this cruise we have a couple of students, Benjamin Aguirre and Leslie Noah, who are from the University of Valparaiso and the University of Magallanes, respectively. Buenas tardes a todos, es 10 en la noche, hora local. Estamos en una inmersión frente a la plataforma de hielo de Jorge VI, otra vez. Mi nombre es Matthew Lee, soy investigador del Centro IMA, Universidad de los Lagos, en Puerto Montt. Y estoy aquí con mis colegas Dr. Américo Montiel y Cristina Aldea, que son de la Universidad de Magallanes. Y también trabajamos con Dr. Geological Soto de la Universidad de Valparaiso. Además tenemos a bordo un par de estudiantes, Benjamin Aguirre de la Universidad de Valparaiso y Leslie Noah de la Universidad de Magallanes. Y bueno, cuando aclara el agua, vamos a ver qué hay. Sediment.
Bridge updated position.
Updated position.
eso?
¿Lo quiere? Mirarla. Y si buena,
Can we have a relook at that rock?
I want this rock.
I want to look at it first.
I'm just gonna sit down because it's messy in a hurry.
Yeah.
I like it, I can't take it.
Yeah, okay. Let's pick up a rock.
Then we've got a mission for you. Which one?
The red one.
The red one. The one big. Might be slightly bigger than this side. You stop the ship there, Ben?
Andy set the record the other night.
Bridge, ROV.
ROV bridge.
Hey, would you mind pausing the move, por favor?
Pause in the move for Brock. Alright.
Think that. Where do you want to get both nips?
We got one the other day. It was so big the vlog was listing the board the whole way up.
Did it squeeze all the
Squeezed all the mud
bags
out of the bags, yeah.
Ooh, you might be able to do it. That looks like kind of a narrow-ish spot. It is a beautiful I fall in love with the night there. It's big. I mean, I can get this if you bump it down the hill or something in 30 minutes.
being sassy.
Not me, Ben. I wish we could zoom in. I have no idea. I can tell.
No, la gana de explicarlo cómo está todo recogiendo.
Bueno, tenemos una vez de geólogo para eso.
Explique por qué estamos sacando las rocas.
Sí, que tiene que estar el que tenemos a bordo el todo peloso, el servicio de Geology and Mine. No escribo mi letra.
No. Too big of a mouth.
Is that it?
Too big of a mouth.
This? Yeah.
Why take so much stone?
I mean, if it's not doable, it's not doable.
Do you want
I mean, if you can't get it, you can't get it. Them's the brakes.
got a scoop? You got a scoop too?
The scoop?
Do you wanna, can we net this? You're not gonna use the net, right? I can scoop this, let's scoop it.
Try scooping it.
You wanna scoop it?
Yeah.
Let's scoop it. You think you can scoop that?
Yeah.
You just wanna bounce it on there, huh?
Yeah.
Alright, I see what's happening.
It's not a challenge.
I
That's the scoop.
On the outside and inside.
Is he filming?
Always the same.
He's good. That's gonna be the other rules. You spend 5 minutes pushing it around to see. Okay. But watch out. You want me to move over too? Yeah. Okay. Coming up. That was without any thrusters, but I was just vertical. Don't you try to set up excuses. I see what's happening. It's good my winchman decided to give me my slack. Give me my slack. Give me a slack. Down, success twisting forward, maybe clear some of this out. Give you a torch here. Okay.
Hello everybody, my name is Americo Montiel, co-leader of the group of scientists here in the control room of Sebastian. The leader is Matthew Lee. We are joined also with Christian Rodrigo and Antonia. We are turn over the watch here in the commando. We'll be joined with all the people that is contact with us between 10 hours, 10 p.m. and midnight in Chilean time. And now we make some collection of rock because on board is many geologists and are interested about this material to determine the date and so on of the date of the date of the stone and determine the age of this area geologically. Buenas noches, mi nombre es Américo Montiel, para los hispanoparlantes. Estamos realizando un cambio de guardia acá en el centro de comando de SuBastian. Soy el co-líder, el líder es Matthew Lee dentro del grupo. También estamos con Cristian Rodrigo y Antonia del Instituto Senckenberg. En estos momentos estamos haciendo una recolección de rocas, porque a bordo tenemos varios geólogos y ellos están interesados en poder determinar o datar la fecha de cada una de estas rocas para poder determinar su geología y aspectos de acá del ambiente que estamos explorando en estos momentos. Pobre gente.
Premio o Mercos?
Oh, man.
What's the premio?
Surprise.
Yeah.
Ben quiere un helado para sacar la ropa.
More chocolate.
More chocolate.
Man, see, I need all the energy now. That blood sugar up.
Yeah. This is the best pilot ever.
Pilot. It's only good to see something. I don't know if someone had that. Dump sediment all over the place. Yeah. Adding a little flow going here. Great. Okay.
So there's a question in the chat, and they ask if there are any artists at sea at this expedition. And yes, we have one artist on this cruise, Brody Neal, who is a furniture from Australia. You can also check out his Instagram. Actually, it's a Brody Neal. He has fantastic stuff on there, and he's joining this cruise to get some inspiration and just come along and see what scientists do on board a research vessel. So yeah, if you want to know about him, you can check it out on Instagram.
Really make a mess now. So if he asks for a prize, what's the punishment if he doesn't get this? That's really what we want to talk about. Let's talk about the likely scenario. Perfect. Alright, tell me what you need there, Ben. We'll zoom on there. Let's do it. You can use the other arm too. Like something. You guys might just go push.
So a few days ago, we had the chance to go on a small boat trip. So a few of the crew members took us on small boats, and we go in circles around the icebergs and just had a glimpse of what the research vessel looked like when not being on the research vessel. And Brody actually did some 3D modeling of some icebergs. We also took some ice for him. So he did again the 3D modeling on board, and yeah, we are very excited to see what he's going to do with that. I'm sure he will sooner or later publish some of it, but yeah, it's very exciting.
What's that?
Here we go, put it up like place on that.
It looks like little.
So you
really want that rock. Good idea.
That's it. You might have to hold it. It's fine. You might have to hold it. But
We'll be able to do it.
yeah. We're about to calculate here. You want to keep going?
Yeah, go on. Let's see that. Let's test your limits.
Support on live. There you go. You don't have much on this. You're gonna come from the side, you're gonna come top down. I'm gonna go from the bottom and I'm gonna scoop it up while you hold it in position. Instead of me pushing it out. So you're going just a line to the line. I'm gonna go towards us and then go underneath it. Right. So the side of the rock is the best spot. Just gonna go over. Right. Push that out of that way too. Camera. Just tell me when you're ready. Like your attitude, man. I just want to see this.
Where's the rock? You buried it.
Okay, just get behind the rock. Where's your stick? Just get over here. Right there? That was me touching it. Yeah, that's not fine. But once you get my arm. Okay. Now you want me to freeze or should I freeze? Okay, setting up. Spot. It's frozen. Sure, to the left. Yeah. That's frozen.
So there's another question in the chat, and they ask if there is kind of like a wanted list for this dive, and actually is. So we before each dive, we kind of have a dive plan. So we already know what we want to sample for both geologists and biologists. So we not go like just wherever we want to. So we have like waypoints, and we go from waypoint to waypoint, and then we see what we can gather there. Like, for example, from waypoint 1 to waypoint 2, we collect biological samples, and then the next waypoint we collect geological samples like rocks and stuff. So yeah, we do have a list, but it also depends on if we see something very special, then we of course collect it to get a closer look into it. But in general, we do have a list, yes.
it.
Got it.
And then I'm gonna screw you on.
Pop that in the outboard. That's it.
No, I'm gonna put it back in the
Push.
if needed, yeah.
Working my way to the cords. Back up the line here.
No chocolate. No chocolate.
Sir, how goes it? Goes. Yeah. Oh, well, no. Alright, put you in. So I'm gonna follow inside. So working our way. It's down more, down more, down more, down more. Yeah. Probably notice. I was just making out one just in the beginning. Everything just keeps coming down, coming down, coming down. So we are quite high right now.
We just got 2 rocks. So one in the inside of the pond, one out outside. Depth on, but apparently it's not walking. This one's gonna be that's lock. We get bored. Done before, you don't worry about it. This is going deep. And then this is gonna be a wall. So when the wall comes forward, make sure you're behind it. Don't go ahead of them. But yeah, we're
I was just not pointing directly at the wall, trying to just laugh on it, see better for this, but.
Alright, have fun, gentlemen.
So.
Thanks.
Adios.
Too short. You.
Yes,
What about you, Deb? Happy with it?
I'm coming down. I'm like 30 meters out. So let's just see what happens when we come down left.
Biologists would agree that biological samples are interesting. Vice versa.
Para el mundo hispanoparlantes estamos viendo ahí en el recuadro superior lo que va a ser nuestra jornada de buceo. Vamos a retomar el track que se vio interrumpido en la mañana. Vamos a bajar por una ladera hasta el fondo del valle y de ahí hasta una profundidad de 1000 metros y de ahí volveremos a subir por el otro lado del valle. Pípolo en Valparaíso, Chile.
I was just checking if there was any more waypoints to check before going to sleep.
No, fine. What?
Yeah, this after this is
Yeah. No, we're not even a quarter of the way through. Not 30 of the way through.
yeah, I mean, some of the like
Yeah, that wall looks pretty high. See, come on.
But I'll be there at 6.
It's fast.
Are you gonna take one demo? Andres might want you guys might want ¿Quieres mais pushback? That's not in pushbacks. So maybe there's extra if you want some.
No, come on. I would put some
Take sequitos. A few rocks.
I'm gonna get him on the move. Actually get that waymark way up there, 26. So we don't have to keep getting rid of those. Yeah, 50 meters on 6 or something.
According to this, the bottom's at 966.
Great, ROV, that's an updated waypoint for you. Bridge, ROV.
Bridge, ROV.
ROV Bridge.
There is an updated waypoint for you.
Thank you.
Thank you.
We'll see what it looks like when we start going out. If it's like sheer.
Mm. Yeah. Barrel sponges. It can get really massive. So, 40 centimeters in diameter. Yeah, loads of little sea pigs as well. Big scallops there.
You want the sonar to show on your screen?
No, I don't care.
It's quite big, these scallops, aren't they?
Are these like baby sea pigs?
No, it's a different species.
Oh, okay. It looks like a kind of like a sea pig.
There's loads of them. Yeah.
Yeah. Oh.
No, they're very, very abundant. We sucked up a bunch of them on the last dive.
Oh yeah. I remember.
I got one from the really deep sea on the Canyons cruise, like 3,000 meters. I got them, and they shrank on the way up.
Really?
So I got it like a centimeter long.
How long was it in the beginning?
About 4 or 5. They just roll away. That's a big sponge. It's got to be half a metre out, that one.
Well, there's a lot going on that launch.
Yeah, but when we zoom out, see what those white things are on the top of it. The isopods or polychaetes. You know what, those look different to, I don't know, but they look different to me. Fancy some suction sample?
You want to sample these guys?
See, yeah, please.
That's a
Sure. We're gonna know. Which chart?
Number 4.
Number 4. And put the final.
Of the medium mesh.
So, which would you like to snaffle up? Is the white guys?
Yeah, the white guys at the top. Yeah, just get as many as you can. They tend to cling rather than run away.
Yeah. Tilt up.
But are these isopods or amphipods?
Amphipods.
Amphipods. Sometimes really hard to distinguish.
Isopods, the legs are all the same. Hence the name.
That way,
Yeah.
That's sucking. There you go. Just get him going. Come on, bud. He's holding on tight.
They're tenacious.
That's all right. Use one of his buddies to knock him
Come on, buddy.
Ready to draw, ROV. Can we pause and move, please?
Okay.
Yeah, already paused.
There you go.
The one that's swimming. Give the shrimp a go while you're at it. Give the shrimp a go while you're there. See if he get. I think he's more likely to run away, but no.
Oh, get him. Watch out.
No.
Oh, this. Oh, I see it. That's all good. That's right there.
Fly.
They're a bit more agile, the shrimp. There you go. Right. Yeah, that's good. There is a request here. For the stripy fish that we saw just as we were arriving at the sponge. You fancy trying to catch it?
What stripy fish?
It was probably a little way back. We saw it just as we were coming towards the sponge.
Sure, we can look for him.
Yeah. There's the crew.
Stripy fish.
That one. That's what he looks like. Tom thinks it might be tricky. But you never know. He was maybe 5 meters back, 10 at most. Assuming he hasn't swum off. Back in into the dusk cloud. Rocks with the tunicates on, so anyways, past that. Yeah, just
come across somebody.
Bridge ROV, we're on movement.
On the move.
Did you see a fish?
acorn worm flying. What's the stream?
Hmm? Well, it's just, I mean, a couple screens like with.
Yeah, we can see what we do.
Okay.
Yeah.
Keep going.
No, it's the scallops. I can.
I'm glad somebody else saw the scallop on my face.
Indeed.
It's going to be my new go-to excuse.
What?
The scallops are blowing my face.
Yeah, the other day when they were moving really quick, I think it was the big scallop.
Yeah, it's not responding at all.
No,
Yeah,
it's not.
so it's the keywords for that. Probably the keyword Schmidt so it should figure out which one it is.
This one's dead, I'll figure it out.
Yeah, it's okay. It just needs to be charged. Just throw it on.
No, I took it off the charge.
I know it's this.
Yeah, I don't know which one it is. Here somewhere.
Which?
Could I look at it? I'm getting going, or is it just me? Once it's going, it's gonna go past the waypoint. No, it's in a second.
Shall we? Ahora no te
Updated waypoint.
That's why I like this area.
Yeah.
Still heavier spots.
ROV bridge. I just need to come about 10 meters to port before I can come ahead.
Copy that, no problem.
Set the waypoint 6 at 950. So. Going straight up. We need to find another one of those big polykeys. Do you see that one? Yeah.
That one?
Massive scale levels.
Oh, I heard about that one. The sheds and scales.
Yeah.
It's scared.
Oh, it was scared.
I'm sure it
It was
was.
spread across three pots. You've never seen one like that before, so another one would be nice. Species of sponge. Just have a wee look. It's got the same amphipods as well, look. Yeah. You can see the adductor muscle in the skull, transparent shell. Look, it's that translucent, it's fragile. Yeah. Like that one toppled over and then grew again. Same amphipods again. No, it's the same as the last one. Big maritime. Urchin, some tube worms, some general fluff. Hydroids. Oh, I'm getting stuff back. Maybe there's a current.
So to answer one question in the chat, the Schmidt Ocean Institute is a private non-profit operating foundation, so not by the government funded.
Under the midnight sun. Midnight? Midnight.
Oh, fish. Stuffy fish.
Is that the one? That's the one. You want to have a go at catching it? That is the one.
Get the jar can back up there. I think you're gonna go from the front. He doesn't swim backwards. Oh, come on. that in.
Right.
Yeah. Yeah. You just do the final assault, right? Yes. Terrific. There he goes. Yes. Oh, man. Boom.
Oh, look at that. Wow, cannot see this. He wasn't expecting that.
And that's how you catch a fish.
Nice.
Can we get the jar can back up?
To check it's actually in there.
Probably want to give a wiggle. And we got some mud on it.
Yeah.
Just stuck in it.
So which one did it go in?
I think I had it.
I assume it's 3 or 5.
Yeah, I believe it was 5. I think I did. But we'll be able to tell in a minute.
Wait.
It's an S. It's the S. Yeah. So I think it's just the quad, right? There's only the one S.
There it is. Yeah, 5.
Yeah, 5.
Oh, he's
All right. Oh, he's mad.
Hey.
And indexing. Oh, that's good. Back to here to 6.
We got it.
Oh yeah, we got it.
Tom's gonna be stoked.
No, he is. He's got no way.
Professional fisherman.
Come on. You want to hold on to that thing? We're gonna do some more samples.
That has to go on the highlights reel, doesn't it?
We were getting some good sound effects too.
Tom just said, no way. Super excited.
You can just call me his fish mom.
Yeah, we can go home now.
It's just lucky.
Let's push start. Maybe yeah, I think this is.
Well, you'd expect a nice big
Yeah.
fan of sediment at the bottom. So.
It's a octopus.
Well, that's, you see, that's the effect that the octopus is going for. That effect. I'm a rock, know me.
It's a octopus.
The Maritime.
to answer a question in the chat, we are currently at 928 meters.
¿Qué quieres? Ah, no es cierto. A few meters further back there. Indicate. Is that one just there? Just out of shot below.
Further down the hill?
Yeah, just a little bit off screen below. I think it was. That one there. Eso. See? No. Lower down.
We got.
¿Tiene color específico, no? It's sort of a reddish rock, apparently. That one there?
Bridge, RV, can we pause the move, please?
Pausing the move.
I'm sure that is a rock. I think that's one of those urchins. No, that's one of those urchins that puts a rock on its head.
Right, what's that now?
No. Check is to watch the top of the screen. It's that one. That one. Okay. Is that going to be pickable? Yeah, maybe just about.
That's it. It's the rock gun.
Yeah. Okay.
Actually, stop paying it on it. I'm like 130 meters out.
Yeah.
So I need some slack. See how I'm bouncing now.
So we're using.
Yeah, we're gonna stow that thing. Stow the suction. Can you pay me out? Thanks. Back down. Okay. Yeah, I wish I could stow that thing. I got the suction line. Easy. There you go, look over. Yeah, you're in there. Pull off.
The onboard marine geology and geophysics group needs to obtain rock samples to determine their composition and classification and the geological evolution of the area. On the other hand, isolated rocks may have been transported by ice or icebergs, and their recognition may clarify the geology of the area still under ice.
I got on the camera.
Patience. Other one.
It's a good size rock.
Well, hopefully it's not so big. The last one we tried to get just wouldn't go in. Tried scooping it. It was round as well, so you can get a good grip on it.
Where did it go? Right. I had to go downhill.
Might have done as a track going down.
I think it did. It went downhill, man.
Yeah, there's a slide track now. Gone under the road. But I think that might be it.
Yeah, it's right. It's right up against the. It's right up against the push core.
Oh, that's it. Okay.
Yeah.
That's not another way.
Está pegado al rock. en este campo. Pero en este campo se puede ver. One of the rock baskets, whichever is easiest.
From here it'll probably be the outboard one. You want to picture this? You picture this?
Amerigo, it's a worm on it. Ahí por aquí todo. Sí. ¿Puedo decirlo? Por el chat. Sí.
The good part to collect rock is that always have some animal attached, like this is polychaete too, and another epifauna animal invertebrate.
Right, thank you.
Outboard box.
Yeah, it's better to put the bags on top of the rock.
Yeah, oh no, your inboard. Actually stop. Pitch up. Clear everything. So come all the way around so you can see the rock and then it has the out. So
Inside the hose.
No. Pitch it up. Yeah, now has the over. The hose will move. Stay pitched up so you can see it, dude. You can't see it when you're like that, right? So go ahead and do that. Has it over. See?
Para el mundo hispanohablante, esta es una... se está recolectando una roca y tenemos la suerte de que esta tiene mucha epifauna, como poliquetos de tubícolas que están ahí sobre la piedra. Así que ahí donde se juntan las dos disciplinas, geología y biología al mismo tiempo.
Yeah, outside basket. Yeah. There we go. Thank you.
Grab and start that thing. Let go.
It's a suction still.
Yep.
It's just...
Okey-dokey.
Right. Let's carry on up slope.
squares 100 meters, so the boat's like about 150 meters off. So just let them hang out there. Let's see what this wall looks like.
Uh-huh. Going towards number 7. Yeah? The base of the cliff.
Very much.
So given the fact that no one has ever seen this area here,
No,
I think everything is pretty special.
we're looking at one
It
of those
doesn't matter
just
what we
before
find here,
we came
everything
in.
is
Most
pretty amazing.
corals, I guess, is
We are the first people to
they're looking for on the cliff.
we are the first people to actually see what's been underneath the ice sheet. This is usually not really possible for ROVs, at least the one that we have here on board. So this is a very special opportunity for us that we all cherish a lot. And we enjoy every single dive, and everything we see is very special for us.
No worries.
Yes.
Have fun.
Sponge and a stick.
You can see the deck quite. Were you guys acting with that? Yeah. Back with the fish. Five.
Same species.
One.
No, we got one. Been there, done that.
Sure enough.
skim along this thing, see if that's coral at the far end. Yellowy rock, I think. Maybe some coral. Out there.
ROV Bridge.
Hey, Ryan.
Got a big growler on its way to the umbilical. Can we bring the ship ahead one ship length roughly?
Yeah, that's right. Thank you.
Thanks.
Maritime raptor. Not the tube worms. Yeah. Move on. Ooh, big sponge. Right. That's me done. Thank you very much. Okay. No. Please,
Sure.
I would say goodbye for the.
So, ship's pulling ahead.
Okay, everybody is now finishing our watch. I say goodbye and good night to from the all the team, from Matthew, Rodrigo, and Tony, and me. Good night.
Thank you. Hello everyone, welcome back. There was a switch on our team, and now we're gonna be here for 2 hours. So we are gonna head for waypoint 7, where we hope to see some interesting fauna. And then after that, we're gonna reach hopefully a plateau of sediment, where we're gonna collect some sediment and some molossaurians if we see some. And these because I personally am very interested in looking at the organic matter composition and good in quality and in quantity. And for that, I need to collect some holossaurians, or also called holossaurians, sea cucumbers, and also sediment. For now, we are in front of a rock, and we hope to see some interesting fauna that we can sample. Hello?
Quick.
the moment we are facing rock. You can see some sponges, some tubes of possible polychaetes. You see also some sediment. Very nice sponges as well. Is it okay if we zoom in, please? Yeah, thank you. Yeah, thank you. Yeah, thank you. We've just seen two different sponges, and we are continuing on our way to waypoint 7.
Okay, we just continue.
Do you want to copy?
I could imagine that the other one was full, maybe, so they.
No, there was not a many. It's fine. Okay.
Yeah, we'll copy it.
If you want. Cool. Some crinoids. As part of our team, we are composed by myself, the watch leader, the co-watch leader, actually 2 biologists, and then we also have 2 annotators. One is a geologist and the other one is a biologist. So we try to actually annotate and try to see. And could you please, because I think it's a coral. Yeah, indeed. Cool. Yeah, thanks. Yeah, thank you. We also see in the wall some brachiopods and shrimps. Cool. Muito boa noite a todos, para as pessoas que falam português. Nós agora acabamos de mudar de turno, entrei eu, bióloga, a minha colega, também bióloga, e depois 2 pessoas que estão a anotar, uma é geóloga e outra é bióloga. Neste momento estamos a tentar ir para o ponto número 7, encontramos-nos numa parede composta por muito sedimento e depois esponjas, temos crinoides, já vi alguns corais, camarõezinhos, e depois deste ponto 7 vamos para o 8, onde poderemos ou temos a intenção de encontrar um platô e onde vamos recolher sedimento. To reply to the question on the chat, and yes, we are going to do some Niskin samples, but we are gonna do it when the habitat actually or the ecosystem changes a bit, and where also we intend to collect some corals. And like that, I personally will look at how these corals function and if the food they are filtrating is rich in quality and quantity. Wow. You don't have any indicator of any risk, right? Yeah, close one.
I think nothing was closed yet.
Huh?
I
No?
think nothing.
Yeah, that's fine. Claude, is it
There's a
possible
coral.
that
There
it's
is a
closed?
coral.
Yeah? Oh, yeah. Good. Well spot. I'd like to sample that. I was going to tell you. Yes. Is it possible? I was going to tell you to close actually one of the Niskin bottles, but yeah, after the coral, it's okay. Thank you. I was talking to him.
No worries.
Cool. Because I just saw that there was none done. And it's not very good. I think the person in the chat gave us some luck because there is another one there. 2 corals, one here and then was there. As actually we just spot 2 corals and we're gonna try to have a sample of both and then close a Niskin bottle. See, Claude, here. 1 and 2. As you like, as it is easiest for you.
Bye, good night.
Alright, have we done the introductions?
If you can take a piece, that would be nice. In order to leave some behind, but of course I know it sometimes is hard. We do as you can.
Actually, they didn't upload a dive plan, so I wasn't really on track which dive number it is and stuff. Did it? Did it? Oh, sorry. Yeah, normally there's a PDF or something. Hi everyone, so I think we've just had a shift change recently, so we have Professor Teresa in the room
Master Amber, Master Jessica, and Dr. Sveta. So we'll be in with you for the next couple of hours and hopefully take you on an exciting ride. So Amber, what are we sampling right now since I just walked into the room?
Right now we luckily found 2 specimens of corals. I think it's, for me it looks like it's the same one, but I'm not expert in this, so I cannot really say. So I think we're gonna sample one of them, and then we're gonna close in a skin bottle at some point. And then we continue uphill, and I think at the top, if there is enough sediment, we're gonna take push course.
Okay.
That's the...
So we're doing push course a bit earlier in the dive today than not leaving it to land.
I think they want to do it at the shallowest part, which is going to be the top of this ridge.
Okay. And what altitude are we going to be there?
That is a good question.
Or depth, rather, I should say.
600 meters.
600.
Doctor is here for your medical attention to any questions in the chat. I'm the Doctor of Sediment.
Yeah. Yeah, need to have a, yeah, exactly, photo.
Yes, I am the Doctor of Sediment, and by that I mean I have a PhD to do ocean marine
they are all
sediments.
empty, so you can put it 4A or 4B, it's okay.
So generally in academia we tend to normally do an undergraduate degree, so a bachelor's, then we do a master's, and you become a master. Then we do a PhD, so this is a doctorate degree, which is why it's called a doctor, which can lead to some strange situations, because sometimes people do indeed think you're a medical doctor when actually you have no idea about medicine. And eventually you become professor after many years of service and some good publications. So I did my PhD at the University of Cambridge, and my PhD was in studying marine ocean sediments. So for me personally, I'm really into the push cores we're getting from these dives. I'm also interested in gravity cores that I've also been doing from the ship. And the reason I'm interested in these sediments is actually I'm quite interested in these shells, microscopic shells that live in the sediments. So these are called foraminifera. They're a single cell protist, so they're sort of size of a grain of sand. And these shells, I analyse their chemistry so we can sort of study what happened in the past and the environment they lived in when they calcified and died. So the deeper in the sediment you go, the further back in time you go. And in this way we can use this past climate study as a natural experiment.
4, yeah? 4A,
yeah.
BB, 4A.
Yeah, I got that. So yes, you can use these studies that I do, so the things we learn as a natural experiment, and then we can test the computer numerical model simulations that predict future climate change and these scenarios based on geological data, like the stuff I collect, and the whole community of scientists that do this kind of research, and improve future projections for what will happen with our current climate changes.
Yeah, just say.
You want the honesty before we sample it? Before
Sorry?
we move and stick up the sediment?
Yeah, you can do it here. Yeah, I think it's easiest. Yeah.
It is indeed very cold in this part of the ocean at 800 meters, so the temperature of water depends on the water mass.
It was already cold? Okay. Okay. That was number one. Yeah. This clean bottle one?
So yes, the deep water in the ocean generally, there's very few sources of formation, and the ocean circulation is a conveyor belt of thermohaline circulation. So essentially what this means is that it is driven by the surface winds in the surface, and then you have the bottom belt, which is driven by these density changes in water masses. So deep waters form in the northern North Atlantic in 3 locations, Labrador Sea and 2 Norwegian seas, and then also in several places around Antarctica, particularly in the Weddell and the Ross Seas are the biggest formation areas.
There's a big. Do you want to sample this one as well?
Yeah.
Do you think we can try to get one of the branches where the isopods are? You see them in the very front?
Yeah.
There's like, yeah. I mean, we can try. If they hop off, then they hop off.
And the deep water circulation, essentially, depending on where you are in the ocean, so that stuff from North Atlantic flows southwards, and the same from Antarctica, sort of spreads around all the deep ocean basins, not just into the Atlantic, but also into the Pacific and the Indian. And then you also get mixing along the way, and other recirculation pathways. But because we're in Antarctica,
I didn't look at that point, but I will.
Amazing.
Yeah. Was it the one that Tom wanted?
Yeah, I told Tom, please take it, because Tom doesn't speak up. And then I said, please take it. And Tom had these fish.
Great.
Amber, do you want to tell them what we're seeing right now, these really beautiful corals?
Yeah, there's another coral, and there's what I think are 2 isopods in the front. At least I saw them a couple of seconds ago. I guess it's the same ones we had the other day, but I'm not too sure. If we can get them as bonus samples, it's nice. If not, then there's no big drama. There is one. And then there's your brachiopods behind that.
Yeah, but they're not using the sucker right now, so I shall refrain from sampling them for now.
A couple of sponges, then.
He didn't call me.
Huh?
He didn't call me to help you with the brass.
Because
Already look at them here, the brachiopods.
Oh yeah.
What are you gonna do?
Oh, well, I'm not going to do much with them here. So I've been collecting brachiopods with the ROV. But basically, I'm actually only interested in the shell part of it and not the molluscid side. And their idea is, again, so they're like, the way they build the shell is a bit like a tree ring. So they kind of build these layers as they go. Sometimes on seasonal resolution, sometimes on annual resolution. So that way I can use a micro drill and reconstruct climate for a couple of 100 years to sort of see different chemical parameters, what temperature they lived in, and whether we detect changes, especially with this anthropogenic stuff. And the really cool thing about brachiopods is that in Antarctica they actually live for 200 to 400 years sometimes, in comparison to only sometimes 20 to 30 years in other parts of the world. Because it's so cold, things tend to live here for a very long time. So because we're collecting them, we know they're alive. So then the clock starts today. So as these kind of shells and the rings go back, we can investigate what happened in the very recent past.
Cool. So what you could do on board is to drill
No, I can't be doing microdrill. The only thing I'm doing on board is getting Teresa to help me get rid of the animal from the inside.
Okay.
And then I'm just labeling, bagging up the samples, and I'll analyze them in the future for various chemical parameters. I also got a colleague who's a chemistry brachiopod expert, so I'm sure she'll be very interested to collaborate on this brachiopod project. Normally, we just deploy sort of sediment corers, which are kind of just one point, and you don't get to choose what's in them. Occasionally you do find the brachiopod or two, but I just thought this is really cool that actually I can sample like a few, you know, and have a nice collection rather than just relying on happily finding one sediment. Especially because they're so fragile. If they're in the sediment, you know, they often like break from the sediment buildup, or even from the drilling methods, like the coring, or even when I'm like sieving them, handling them in the laboratory if I'm not expecting to find one. Translation in about 4 hours time if you're still here.
2.
No, 4.
Oh, 4, yeah.
But
And
Professor Tom is listening, so we can ask him questions
Now
to
you
the
got a whole coral.
laboratory.
Yeah. Well, it's so fragile.
Yes, in terms of brachiopods, so the last ice age was actually around 20,000 years ago, so a few hundred years will not quite reach there, but because the area we're in right now...
On a different one?
Yeah. we need to
No,
do
no,
that.
you can put it in 4B.
Okay.
It just cannot be in 4A because of the
I mean, it is large. Huh?
mucus
Yeah,
that they...
it's too big to go in that.
Okay. Okay, then.
We try.
Yeah, it's difficult, yeah.
So what you see in the upper left image is a sea star. They're usually Brisingida or Freyella, I cannot really say. They do look a little bit different than the sea stars you're used to. For example, at the beach, or even here in the deep sea, or not in the deep sea, but here in these waters, you sometimes see these normal shaped sea stars with, I think, what do they have, 8 arms or something? And 5? But these have a lot more, and sometimes you see them also with differing amount of arms. They're not always having the same amount of arms.
In terms of these brachiopods, so a few hundred years, essentially, West Antarctica is currently melting due to climate change, the human-induced anthropogenic changes. A lot of uncertainty comes from Antarctica of how much is going to melt, depending on which will really affect sea level changes worldwide. So what we will be able to tell from this studying the brachiopod for the last couple of hundred years is to see how fast, for example, these glaciers are retreating, perhaps reconstruct water temperature, because this is one of the interesting things that we think the waters, these deep waters, are getting only marginally warmer, but enough so to melt this the ice shelves from underneath. Because in this area, basically the reason West Antarctica is unstable is if they imagine an ice shelf, it sort of hangs out above the sea. So you have like an ice shelf hanging in, and then they have seawater, and then underneath you have the seafloor. And this warmer deep water sort of comes in and melts the ice shelf from underneath, which causes the ice shelves to melt and sea level rise on the planet. So yes, our kind of instrumental data or observational data only goes back to very recently the satellite age. So if we can kind of look back a few hundred years, we can really see is this retreat faster, is the water really warming up faster, and again use this information to try and improve these climate models, like how fast is it going to get even faster, how fast are these scenarios feasible, and what will that mean for climate adaptation, climate mitigation, and future climate change.
Sveta, I will answer this.
Yeah, go for it.
To answer to the question about the coral, I'm not really sure if, because I also thought about that. So this coral, it's going to be used for different kinds of research. Myself, to look at the food web. Also another investigator here that will look on genetics as well. But it's true that I thought about it, that if we would drop part of the coral, maybe it could actually reattach. I'm not really sure about this. I am participating on a project on restoration of corals, and to restore corals we need a kind of glue that we use to reattach these corals to the wall. So to answer to your question, I'm not really sure if we do it like without having this glue. I'm not so sure if it would reattach. I thought about it actually, but yeah, well, at least we will use then the corals for this study, and we're gonna also put it back in the museum.
Do these corals we see here, do they eventually calcify as well? Or are they different type?
Yeah, different type. Yeah.
Someone is asking us about O2 oxygen concentrations at this depth. Does it vary or is it always the same?
Where? Ah, those.
It's in the right chat.
Actually.
But like it's different around the world, right?
Yeah. It's actually what Laura is doing. So I don't think it varies at this depth very much. It varies a lot at the surface until it reaches the oxygen minimum zone. And at the moment, because of climate change, this minimum zone is actually going, I think, shallower, I think, and then this affects lots of marine mammals and also fishes. I actually have a friend of mine that her PhD is actually to study whale sharks and the effect of this switch of oxygen minimum zone. What does this affect on whale sharks? No, it's good. Thank you. Yeah, her PhD is really cool, and it's really about the impact of climate change in whale sharks, and because the oxygen minimum zone is switching, then it is actually affecting the trajectory of the whale sharks in the world. So it's actually very interesting PhD.
That does sound a fascinating PhD.
But very hard because they used to be in some islands in Africa, and now they are actually not there anymore. And so our task is also to have a kind of a thing that she puts in the shark in order that she follows the shark and sees how the shark moves according to this oxygen actually.
Oxygen is a very important thing to sustain any benthic animals and marine life.
We can go. Yeah. Thank you.
So essentially, for these things to live on the seafloor, generally we need food. So this depends on the type of creature that we see. Some of them just feed on organic carbon and nutrients coming down. Other bigger creatures are carnivorous and eat other animals. And we also need oxygen for like any living thing they tend to respire. So sometimes you do get these oxygen limited environments which don't have much biology going on because life cannot be sustained. And here on board we have two oceanographers. They've deployed two gliders. So these gliders are these autonomous underwater vehicles. And these vehicles, they have different sensors. So they've been piloted by people back in the UK where the oceanographers are from. And essentially, they go down into deep water and then come back up sort of in a V shape and do a transect along. And that once it's up, it catches GPS and can be reprogrammed to go in various directions. These gliders have different sensors, so we get some temperature, salinity estimates, and things including oxygen. As Teresa was saying, we have Laura and Meredith, so they're doing the study. And they are indeed interested in how this oxygen changes. So actually that is one of our research questions here for the oceanographers on board. So I'm sure there will be more information coming out of it once we especially recover the glider, get the data.
Can we shift a little bit to the left and see what is up there? Sorry.
There's more corals.
Yeah. And I think Aaron would be. Is it okay if we just one of them, please? Not all the corals will actually be white. So some of the corals, they live in symbiosis with an algae. And whenever the temperature is hotter, the algae dies, and that's why the coral becomes white. It's what we call bleaching, but not all the corals live in symbiosis with an algae.
Teresa, do you know what type of corals are these?
Yeah.
I'm sure you do,
Yeah, the sclerotidium, so they have a skeleton and they live in symbiosis with the algae, but not these ones. We have a lot in Cabo Verde, which is a country where I actually am leading two projects. And last year we had a dramatic temperature change, so the waters became really hotter. It was about 28, 29 degrees, and some of the corals, they all actually got bleached, so they become really white. But fortunately, we went back to the place, and actually they actually recovered, so it's really good news.
That's really excellent that they recovered.
Mm-hmm. Or some die and they were just not there, or they recover. We don't know, but we are measuring these, and sooner we are gonna analyze the data.
And Teresa, for when we're getting push course?
It's when we reach the plateau.
I was just going to say when we're getting push course later, I think Matt said I can have his 3, so 7 in total for me full of sediment, please.
Okay. Relax, we are not yet there.
I'm on the edge of my seat for my sediment. And Dr. Sediment wants the sediment.
Yeah, we use.
Immediately retracted. Immediately retracted as soon as you touch it.
Yeah.
Interesting.
All of them. If you see, they are all with the polyps out. As soon as the arm gets it, they all close. Yeah. It's actually very cool to see it.
Yeah.
And what is the animal on top of that coral?
It's another isopod.
Grasshopper.
Marine grasshopper.
Climber. Short. Yeah, thank you.
Beautiful one.
Yeah, thank you. Wow, cool.
That's a cool zoom-in picture.
Yes.
Yeah, we are working on this data, and soon I will be able to tell you more about this effect in Cabo Verde.
Do you have more field work planned on Cabo Verde?
Yeah, in October, and now, well, I have 3 field works in Cabo Verde. Now in April, I'm going on a cruise, actually looking at food web myself on corals at different depths. And then I will be going in September to finish up the impact of climate change or temperature change in some of the corals. So we have several transects that we have access, and now we're gonna measure how many died, how many recovered. So yeah, it's one of the final field work that we're gonna have there. Thank you. So number 1.
Yeah, we got that.
03. Yes, last year there was an increasing of temperature in the ocean. If I'm not mistaken, was due to the El Nino effect, but at least in Cabo Verde the impact was not very serious, because I think, and just looking very briefly at the data that we have collected, it didn't really have major effects in the fauna.
That's also very good news. Yes, ocean temperature is a difficult one because the ocean is not uniform. Essentially, you have different basins, you have different depths, and the ocean itself is actually made up of these currents which move in different directions and originate from different places. So it is very hard to say. This is why we use these computer simulations. So we do oceanographic observations. For example, using these gliders, or we deploy floats. So on our cruise, we're actually deploying 2 floats. These stay in the water for a long time and transmit data back on shore. There's now quite a good coverage of floats all over the world. A float is a little bit like a buoy, but essentially goes up and down in the water column, and when it's up, it will send GPS data through to land to the people that work with this type of data. But as you can imagine, that is still points in space, so we have to do some interpolation and kind of work around. And there are areas which are not as well covered as other areas. For example, in Antarctica, there's way less floats and observations being done, so actually this cruise is a very exceptional opportunity for all of us here, the biologists, the oceanographers, the marine geologists, we're finding loads of new things. And I guess for anyone that's recently joined or has missed our last few days, we're currently in an area that is essentially sub-ice shelf. So an ice shelf, this area was completely covered by ice shelf only about a week ago. We were doing some research in this area, and we're kind of just around the corner studying the seafloor. Then this big berg moved away. It was really big, up to 40 kilometers, if I'm not mistaken, in length. And so we were able to access this area, and it's very interesting.
We can go. Thank you.
So Amber, do you want to tell us what we see on this rock?
We see corals, we see sponges, we see crinoids, we see shrimp, or 2 shrimps, one bigger, one smaller. Sea stars, one on the left, one on the top. I think there's some bryozoans on top. The spiky thing on top is also a sponge.
Which one is bryozoans? I've only seen dead ones in my sediment.
These ones should be bryozoans. Then we have your brachiopods.
Yes.
I don't know what this reddish thing is, though.
Is bryozoans, is that an animal or a plant?
Bryozoans, I think.
They're animals.
It's an animal. Cool. So they're similar to a coral then, I guess.
Well,
completely
different.
Do they have like polyps and algae kind of symbiosis as well, or they're just a sole organism?
No idea. I'm over-questioned with that. I just know that they make more or less geometrical shapes. When something is really small, geometrically woven, then it's mostly, from my experience, bryozoan. Do we still need to do close-ups of cup corals? Okay, that was one. Oh wow!
That's
Look
very
at that.
beautiful.
Cool. Yeah. It's a hot spot.
We're just gonna zoom in and all
The
these
things with the
sponges.
holes are tunicates here
Oh,
in the
that's-
back.
Oh, cool.
Nice. Yeah.
What is that?
Question.
So
I just know that they're very
different
jelly.
Thank you.
Yeah, these ones are tricky because
Very
they
cool.
totally look like anemones, but mostly
Yeah.
they're cup corals, which means they're not anemones but corals.
I think my experience with bryozoans is I recently found some in my segment course, and actually I was totally convinced it was a coral when I found it and got very excited that I can use it for my chemistry experiments. And then some biologists told me that I'm silly and it's just a bryozoan. So now I'm not sure what to do with it because it's fossilized and I think it's around 9,000 years old. And I actually been meaning to read up what is the skeleton made out of and whether it kind of serves as a climate archive or not. But I know what you mean about the geometric thing because then I looked under it under the microscope and it's like a really cool kind of pattern. So we're just going up this nice rock wall, and the reason the topography is cut out like this here is because it's an environment that's got this glaciers that flow, and essentially when a glacier falls or flows or an ice sheet is a little bit like a liquid, like a river beaving, although it's actually a solid. So just from the sheer strength, it basically cuts out this topography in the ocean floor. And because this area until very recently or a few days ago was completely covered by ice, we don't have as much sediment around here because it's just not had time to accumulate yet as other areas that we've explored so far in that cruise and generally in other locations in the world. So that's just why we still see these big rock walls sticking out. And I think they make, from my understanding, interesting things for biology because there's often these organisms that attach to them and grow on the rocks. Is that right?
Sounds right.
Why do biology organisms like rocks so much?
I guess because some of them need hard substrate to attach themselves to. So for example, where we normally are most of the time, or where we normally focus our study on is the Clarion-Clipperton zone in the Pacific, and there you have manganese nodules. And you see that some of the megafauna is way more abundant where you have fields of manganese nodules that are also, sometimes you have bigger nodules, sometimes you have like huge fields of smaller ones, but you can really see that some of what you call sessile megafauna only appears in these fields or has a way higher abundance because they need hard substrate to attach on and to grow on. And then you have mobile megafauna, which is able to move and able to like either crawl or walk or whatever. These are not so dependent on the manganese nodules, but you still see that they have higher abundances in those nodule fields. So I guess, most of the things that you see here are way happier if they have some rock to sit on. And I also think that some of the stuff filter feeds, so when you position yourself on a wall where there's currents or stuff, then you have a pretty cozy place to hang on and get some nutrients and stuff.
It's also for refugia. They get there, to hide from the predators.
Mm-hmm.
the 2 inches that you are the 2 dots people see on the screen, it's actually about 10 centimeters, and it's for us to estimate actually the length, the width of the animals we see later on.
And what is a predator for a sponge?
Good question.
Sponges tend to be a little bit spiky, so I was just a little bit interested.
Claude, sorry. That would be. Oh, it's yeah. Please.
Apparently, some species of mollusks, fishes, turtles, and sea urchins like to eat the sponge.
It's the last one. So.
Is that a cousin of you, Jessica? There's your sea. Yeah, there's your holothurians.
Yeah, they are too deep yet. I want them shallower now.
Okay.
So, Teresa, you're going to be up all night till we get to the shallower area of the dive to catch some holothurians today.
Yeah. And all day.
Me too. So we've all been getting quite tired because this area is so interesting that we're actually doing dive after dive on board. And it's super fascinating, but we're really starting to feel it. So I think tomorrow night, tomorrow afternoon we have another dive, and after that
I'm gonna be dead.
You're gonna be dead?
I will die.
Yes.
Because I will be 48 hours awake. So.
Oh wow. So yes, this is what some of us are pushing ourselves really to that limit, just making the most of this amazing opportunity to be here on the Schmidt Ocean Institute Falcor 2 vessel. And then, but good news, Teresa, is tomorrow night we shall be doing some mapping. And I think everyone is really happy if the mapping goes on for quite a while. And I'm sure our geophysicist on board will also be extremely happy to do long mapping sessions. So.
Oh, cool.
Nice.
Nice.
What is that? What is the thing on the right?
The right? Here.
I think it's a scale one. Looks like the part of the rock.
Look at all those
Could be.
prawns attached to the coral.
Wow. Yeah. Nice.
Oh, it's about happy family.
Very beautiful.
No, these things, so the ones we sample from the ROV are also the same colours actually when we bring them back up, so they generally are these colours.
Yep. Oh, I need to sample. Yeah. Let's try again. Must be very hard, right, for you guys to disattach just a piece. They are
It's
very
too
fragile.
close.
Yeah.
The branches are too close, so you can't hold one branch. Even though you get one branch, it still doesn't want to break off.
Yeah.
Are we sampling this coral?
Everything is getting one branch.
Danke, Toni.
Yeah.
Schlaf gut.
I think it's gonna break.
Not the same. Here, that one is here. And it's not possible to use the 2 arms? Okay. Like to help? I don't know. Never used an ROV before.
Yeah, it's gonna be difficult.
So is this coral, Therese, is it for you, this one, or is it for
It's
everyone?
for 3 people.
Oh, so you guys are all using the same type of coral? Okay.
Yeah. So unfortunately for biologists, we have what you call statistics, and you cannot really say something about an organism just because you have one. If you have 3, and if they say more or less the same, then we can, say what's happening. But then imagine if these 3 organisms from the same species, if they say something completely different, then we have a very big problem. So in biology, it's always better, of course, to have 5 or 7, but I don't like to destroy the system that I'm using, so I try to use the minimum. At the same time, we are a lot of people using the same organism, so I think we will use it almost all, so I think it's okay, and then it's also the last one we will use and sample.
Okay. And it's you, Erin, and who else?
Sorry?
You, Erin, and who else?
And also the people from Chile that we'll also put the coral in the museum.
Mm-hmm.
Yeah. Also genetics, food web, and morphology as well. We can also say something about colonization. Yeah, you can do a lot of things.
Sveta, by the way, do you know of the ice sheet that broke off? Is it an ice sheet?
Shelf.
Ice shelf that broke off has a name?
George the Sixth.
So it's part of George VI?
I believe so.
So the one that is still remaining intact is also George VI, and
Yes,
then a baby of George
is
VI.
very big, yeah. So generally when ice shelves start breaking off, it's kind of carving. It's a bit like a cliff, if you imagine, that's been eroded by the sea as you approach. And like from the kind of erosion underneath of that cliff, so the sea kind of destroying it. Similar thing with an ice shelf. So basically the ocean kind of gets underneath, melted, becomes, and it moves further in line, this grounding point, which is where the ice shelf attaches to the rock underneath or the bed. And then eventually, as there's so much overhang, it becomes unstable, so it breaks off, and it's the icebergs that we see. And normally it only just breaks off a little by little in small icebergs, whether we were lucky that such a big area opened up very quickly, and also I guess on the wind direction that iceberg moved away quite rapidly out of the base, so we were able to go in and explore the area.
Okay. So they don't immediately get a new name when they're not attached to their parent ice shelf anymore?
The iceberg, I think it has no name. It just eventually it'll just float around and it'll go more north, so into higher latitudes, lower latitudes, and then eventually melt from just the warmer waters. But the George the Sixth thing, if you Google it and see why, it's actually quite long. So it's just part of that ice shelf. I think originally we were in this bay area in the first place called Ronnie Entrance because there's 3 ice sheets, I believe, that kind of this area serves as an outlet for, so that means that where they kind of eventually carve and kind of flow into. And I think we were really interested to do the mapping to see how that impacts on the seafloor and which direction all these ice shelves were kind of moving in. And obviously this happens, so now we're investigating immediately what happened underneath. When these ice sheets move away, these ice shelves, they leave these beautiful patterns on the seafloor, which is what is of interest to geophysicists, the mapping. So these patterns both in the sediment and in the rock of how the ice sheets moved in what directions, and sometimes you can even reconstruct the sort of timescales, the chronology associated with these events. So it's called essentially marine geomorphology.
Is that
kind of study.
1 second, I think that's a polychaete. Oh, that would be so great if we could go with the rest. This one.
That's a polychaete?
Yeah, I think it's not a nice pot. It looks more wormy. Yeah. Yeah. on, little boy. Hold on.
Hold tight.
Yeah, good, okay. That was it.
Is it gone?
No, it's crushed in between the
Oh.
claw.
Yay! Good. The glamour shot. It's perfect.
Stay right inside.
Yep. Thank you. Great. 356.
Ah, yeah. Polykeys, they're cool.
With the polykeys.
Yes, great. Thank you.
Thank you so much.
This sample will make multiple people happy.
Yeah. A medical use the polykeys.
So this morning, on this morning's dive, I believe people found some new species of polychaetes.
Yeah, one species. Yeah.
Okay.
It's not really yet sure if it's a new species. I also have a piece.
Very nice. What are you going to do with this?
Isotopes.
Excellent. What are they made out of?
Sorry? No.
Polychaetes.
Where they belong in the food web.
Oh, but what? So you're doing carbon and nitrogen isotopes?
Exactly. Yeah.
Very interesting.
Para os nossos ouvintes portugueses ou do Brasil ou de pessoas que falem português, para fazer um pequenino resumo daquilo que está a acontecer. Nós estamos numa expedição científica à Antártida. Neste momento estamos a fazer um transecto na direção do ponto 7. Acabamos de mostrar 3 diferentes corais. Estes corais vão servir não só para a genética, para verificar a espécie, mas também vão ser usados para as cadeias tróficas, que nos vão informar de que é que estes corais estão-se a alimentar aos 760 metros. So we finally go to waypoint 7. Thank you.
So at this waypoint, we just plan to continue going to waypoint 8 and stop if we see interesting things. Is that right?
Yeah, and where we might find a plateau and where we might actually look for sea cucumbers and push cores.
Okay.
So we're gonna go up the hill. I think we will reach about 600 meters or 600 and something, and it's where we find the plateau.
Did you help to plan this dive?
No, I did
Oh, you
not.
didn't?
No, I just know that there was a change. I think we wanted to go somewhere else and then we couldn't because the ice
Yes, we
situation.
wanted to get to a really shallow bit, I think, and then we came here, which I think is near the previous dive, but I was just wondering whether you know, in like...
It's the same kind of dive we did yesterday, but in a different location. So it's gonna be good for us to actually do a comparison, because the dive is more or less the same depth range of yesterday. We could not go to the shallowest place because of the ice, like Amber said, and we are planning to do it in the morning.
Yes, I know, so we've got another dive, right?
9 o'clock.
If the ice allows.
Yeah.
I think if not, then we're gonna continue to the next station, actually. That's what I understood.
If not, it's good news for me and Jessica, because we're gonna sleep.
Well, yeah. And me. And then we can all do some relaxed mapping / sample processing.
Because you are doing nights, Sveta, but Jessica and I, sometimes we do nights, other times we do days. I don't know what I do anymore.
Well, this is the problem. I was hoping to do like so my cutoff was breakfast, that I go to bed before breakfast. But it has now escalated that I go to bed way after breakfast. And if tomorrow, if we do, I mean today, if we do the second dive, then I'll probably get to go to bed at like 11 a.m.
Yeah.
You know, and that is next level. I have not gone to bed past 9 a.m. so far.
Yeah, exactly.
So you always attend breakfast?
No, not always, because I'm normally awake at breakfast these days, but I found if I go to breakfast and I'm like, you know, eating food, I'm quite full, and then maybe I want to go for a cigarette, and then I get some fresh air and it's sunny, people start waking up, I get chatting,
It's always
and then
sunny.
I just struggle to go to bed.
It's always sunny.
So I prefer to skip breakfast and just like, I have go to the mess before breakfast and just have like some cereal, or like, depending how hungry I am, third dinner of the day sometimes, you know, from the leftovers, and then some tea, and then I go to bed, because otherwise, yeah, it just wakes me up too much, the breakfast.
So do we have anyone here who's regularly attending breakfast?
I
That's
don't.
my question.
I do fasting.
Okay.
So I normally have 17 hours without eating, which is good.
But generally breakfast actually, when I've been for a few days like recently, it's mainly the crew. I don't think many of our science party make it to breakfast these days.
Yeah, Sophia.
Sophia,
Oh, Sophia.
is always there.
This is very funny. So I arrive at breakfast and normally by that point I'm feeling quite destroyed.
And Sophia just woke up.
And Sophia wakes up and she's really a morning person, so she gets really chatty at me and I'm like, Sophia, look at my bags under my eyes.
Wait, there's a fish. Do you think that fish is of any interest? Or is it just normal, usual red tails?
I have a challenge for you.
Yeah.
But I know it's a very big challenge.
But
do you think we can catch this fish for Tom?
Professor Tom.
Pretty suction?
Yeah.
Okay.
But if it's just a red
Or-
tail, then it's not gonna
Last
be
time it was
interesting.
Joel did the section, I don't know.
Yeah, I think he wants to. So yes, the other day, Amber, I went to breakfast and Sophia comes in and starts really being very lively morning person. So I sat a few seats away from her, still on the same table, but like moved away because I wasn't really in the mood to get really chatty at that time of the morning.
Yeah.
And then I think she was upset and she really wanted to discuss new scientific meetings.
Okay.
So I had to quickly eat my food and depart as soon as I could from the breakfast.
Yeah. Grenadier. Maybe the big guy.
Professor Tom really likes this fish. He's just online.
Yeah, I know.
Listening to our chat. Yeah, I saw. But I'm just explaining to everyone. So Professor Tom is our local professor of fish. He is currently not on shift in this room. However, he is down the corridor in the laboratory performing some experiments. And this live stream is also broadcast to the laboratories on the ship, so you can be essentially doing something else whilst watching what's going on. So, for example, if a fish appears and if it's of interest to you, then you can join in and message our group chat asking, please fish me out the fish. And we can also consult our professor of fish and about the type of fish that we're seeing.
No, but what my question really was, did you ever encounter pancakes in the morning?
Yes.
Oh, are they frequent or is it something rare?
No, it's quite. I only saw them once, and they were
Okay.
like banana pancakes.
Okay.
Oh no, actually there was a day we had like crepes, you know, like the French style crepes with Nutella. That was a good day.
Yeah.
So I have this dilemma every morning whether to go to breakfast or not, because I really want to go to breakfast and eat these nice things, but then also I know that then I'll be awake for like another 2 hours, and it's just not helpful to my tiredness levels. So it's really, last night I actually went to sleep at 6 o'clock in the morning.
Cool.
And it was a really early night for me, and I was really happy, except I got woken up today by urgent core extruding. So.
Alright, I'm keeping that on.
Okay.
We see you later.
I didn't find you at 5:30. I woke up and I came to the ROV.
And you can find me.
I don't know.
I was in the mess until around 5:30.
Ah, yeah, I came here.
Because I left here at 4 o'clock after my 4-hour night shift in the ROV room.
It's 10:04. That is a beautiful wall. So much stuff on there.
Yeah.
I agree, it's a very beautiful rock.
With some unnecessary decoration.
Yeah, Christmas tree biological decoration specimens.
is, yes.
Oh, we're going to see if we can catch the fish for Professor Tom. I hope you're bracing your seatbelt, Tom, in the lab.
What do you need this? Cup coral. Ah, cup coral.
5-4, over.
Yeah, you look for sure, right?
The fish is like, what is that?
What's that?
Oh,
Sorry, swoop. Okay, swoop.
okay.
Coming up. Face it up. Face it up.
Well, I think you've got it.
Yeah. Cool. Hey Tom, we got it.
You can
Wait.
unfasten the seatbelt, although not yet. Let us
No,
pack
not
it
yet.
away. Oh,
It is quite big.
Where are we putting it?
I think
Firebox?
no, because I think then it will escape, don't you think? Maybe if you put the net, not so sure. Tom, can you come to the room? Maybe you have an idea where we can put the fish?
please hurry, Professor. Unbuckle the seatbelt quickly.
Oh wow.
It is big.
Maybe you can leave it on the net.
Yeah, or maybe put it like that on
It's a
the,
pretty good thing.
or the bio box and they put it like that.
Firebox 2, right?
Yeah.
But then if you put it in the bio box, if you then open the bio box in the future, it will run away, no?
Yeah, but you can't.
Alright, I'll put it in the box and try to tangle it after eating it. Extend your right arm up. Put it in your box back. Yeah, but then you buy a box to do it. Why do you want it only in the buyer box?
Yeah, it's okay if you
Okay.
if you manage, it's fine.
We have nothing in this.
Before all you are.
There's a rock in 2B.
Teresa, Jessica says there's a rock in 2B.
Put it there and don't open it. Don't open it.
2A then, yeah. Well, the rock is fine.
Yeah, I'm just saying you put it there and then you don't open it.
Yeah, exactly. Yeah. In 2B it's fine.
Is 2 is completely empty?
2B has a rock, but the fish can go there. It's fine. Or in 2A, and then we don't open that anymore until we retrieve it. We make a note: do not open
The bio box.
bio box 2B.
And 2A, because
I mean, if yeah, correct.
So might as
How
well.
big is the coral in 1B? There's nothing else fitting in there, right?
Yeah. The corals are in 1. So Tom is here. I call him.
Professor Tom has entered the room to help
What
with
do you
the fish.
think? We are putting in the bio box, but what do you reckon?
Is it too big?
It's quite fishy.
It's going to be a lively one, isn't it?
Yeah.
It's one of the bigger ones. And then that would mean that you couldn't use that bio box.
Yeah, but it's fun.
You could try. It'd be a risk, but you could try twisting up the net and putting it in one of the the rocks, and hopefully it'd stay tangled up. But it looks quite close to the entrance.
Yeah.
It's going to slip out into the bio box.
Fred, I was
Yeah,
watching.
Fred, it was.
Fred, I was
yeah,
watching.
Fred, it was. No, it's still alive.
Professor, how much do you want this fish?
It is a good fish, but it can't paralyze the ROV and knock out a whole bio box.
I already have a rock there.
So perfect. Mine and yours together. Rock and fish.
Together forever. You could maybe do one of the rock boxes if you dropped it with its mouth tangled. And then you've not lost any capacity then.
But then it ran away last time, right?
It
Because
got out of the bio box last time.
Oh,
Yeah.
really?
Yeah, yeah.
Of the bio box?
Uh-huh.
Oh.
That was the Bucky
Oh.
Draco.
Oh,
Just-
wow.
It was just fast, but I think this one is.
Oh no, it's still in the net.
Yeah, yeah.
Oh.
Of course it's there.
But I thought we put it away in the buy box.
Because you can't close it with the net. You've got to
Oh,
get it
s-
out of the net, which is
Yeah, oh,
a
the
danger
fish is
zone.
stuck in the net.
Mm.
Good catch there.
I think it gave up on life already.
It might be a bit tangled and exhausted.
Oh, I want to see it.
It looks
Whenever it. Oh, it's really cute.
Yeah. Nice.
I want to see it when it comes on deck.
Yeah.
So has that gone into the rock box now? Or is
Yep.
that
Yeah,
basket
the far
hold?
one.
Rock box 2? Amber, where has that thing gone? Is that this one?
Yeah.
Or
I don't know. Which one is it?
rock box 1?
I think it's that one.
Do
Where the
know.
net usually lives. There was a rock in there already.
Here, right?
I think so. That's the one.
Maybe I should add some more rocks to there to kill the fish so it stops moving around.
No, because then you destroy it. That's not the point.
It needs to be an immaculate museum specimen.
Exactly.
Oh, I
No
see.
rock bumps on
Okay,
its head.
no rocks. I'm limited in the rock collecting today. Damn. Where is the... Oh, it's because for rock box you have to log it as a geological sample.
Oh, it's the only way it can go in the rock box.
Oh. Well, because I already took a picture.
Nice. So,
It's excellent. Two fish on this day.
two fishes, right? So,
Really good. Keep me busy.
and with two different methods.
Teresa,
Huh?
can we get some advice on how to log it? Because there's no
A rock box
option.
for biological sample, and if I log it as geological sample, then there's no picture now attached. Cause
And nothing
already-
like fish net or fishing net? or
No,
anything?
there's only like bio boxes, coral weavers.
Just put it and then put it as a
But-
comment.
Can we
A
put
I
comment?
have
info
to choose a
track
location.
Huh?
I have to choose a location, otherwise it doesn't let me submit.
Oh,
Maybe just pick one of the bio boxes and then say in the comment
yeah.
where it actually is. And we
Thank
will-
you.
At the
Thank you, Lex.
free text event.
Yeah.
Is it number 1?
And as long as the next team have the paper copy and
Well,
know that
I'll
that
still
box
be
is
here for the
available.
next team, and then you're coming in, so that plays fine.
Oh, well, there we go. Won't forget that now, Harry.
I'll log it as a geological sample as well, just so we know that the box is blocked. There's a nice little octopus.
A Dumbo, yeah, I think.
But you like those octopus?
I like them more when they start moving.
Yeah,
But
when
so
they are
far I've
moving,
only
they are really
seen
cool.
Sleeping ones, right? Like I've
Yeah.
been in a few shifts now, and they're always sleeping.
Yeah, no problem.
Thank you.
Let me just look out of the window before I move.
Yeah, no worries.
Some scallops on the horizon. Now there are specialists who study scallops. Not on board, but generally there must be, right? No?
I only eat them.
I eat them too. Well, I keep thinking these ones might be nice to collect and have a little taste for our maybe dinner on the transit home, but we have not so far done that.
I mean, I guess we have some people who study these on board, no?
On board?
People working with mollusks, don't know?
Maybe Christian, don't know. Is it still possible to have a close look, or we are too far? Thank you. Yeah, great. Nice. Thank you. Nice. So it's here. We're gonna go for push course and all those things. Here.
Is that 8? But I think we need to, it says we need to do this video transect from 8 to 9.
It's now, yeah.
So I'm staying on for the next shift with the next science party, and I've just texted the next people who will be coming in to sit here with me, asking them to bring chocolate for our shift, because I feel like it's reaching that point of the night when I need my pudding after dinner, my second dinner that I've just had before this shift started. It's quite funny when you do things like night shift or semi-night shift, because the mess or where we get our meals is still open at normal times. Essentially, then I end up having like 3 dinners a day, and I don't really know what's breakfast, what's dinner anymore. And my cabin maid, normally she gets up for breakfast because she likes to get up quite early, so I ask her to leave me actual breakfast on the side, because otherwise I just have 3 big dinners a day, you know, steak and ribs for breakfast, lunch and dinner. So I've stopped calling it breakfast, lunch and dinner. It's just second dinner, third dinner of the day. It's a meal. It's a meal, quick energy.
Or you can be British. You say you go for
Supper.
Supper, yeah.
Indeed.
And you go for tea, then you go for supper.
I do indeed go for tea quite often. And you know what's funny actually, living in England, so I'm Russian originally, and actually in Russia we drink a lot more tea than what I've experienced in England. People in England say they like tea, but I don't know, I haven't seen that many, like they like their coffee, and they like a cuppa, which is this very strong black tea with some milk.
But the
funny,
expression,
our ROV pilot for today has heard my chocolate piece and has been very kind and given me some chocolate. Thank you very much.
But going for tea in the UK means that you go for dinner. It doesn't really mean that you go for a cup of tea.
No.
So that's
a
fine.
Cuppa. But yes, and it's funny, I like some nice teas, as in actual teas, but my British friends do not seem to like them. But on board we have a very good supply of tea and coffee all day around.
Good.
So we're never short on tea.
I only drink tea if I'm sick. I'm a coffee drinker.
And I have become an espresso monster on this cruise.
Well, I don't go to your cabin more often to drink because.
Thank you, Sunny.
No problem.
Another rock.
I love a good rock. But I just wanted to clarify today that I'm actually Dr. Sediment, not Dr. Rock. Because my research is actually about the sediment, not the rocks.
Oh, can you zoom in, please? For Anna. Thank you. Nice.
But what is the little pink thing above this thing that we zoomed to see it? Like,
Above or the,
yeah, above
the thing itself?
No, this thing. There was like
It's the same, it's antomastus, it's just retracted. It doesn't have this.
Can you tell us more about it? What is it?
It's a coral.
Okay.
That's all I know. Cannot tell you more about that.
How have you been finding shift patterns? Are you going to sleep after this shift, or are you staying up
No,
to
I
process
don't know. I don't
calls?
sleep too bad. I get my 8 hours of sleep. I don't have too much responsibilities. So just doing my 2 times of 2 hours here and then some push coring in between. It's quite fine. I'm not complaining. I'm not low on sleep or anything.
That's good. Are you going to sleep after our
There's
shift?
a massive amphipod.
You're going to sleep after the shift?
Yeah, I guess so.
Just for a few hours before we do the coring?
No, Pedro and Gina are going to do the coring in the morning.
Oh, I see. So you and Tony can get some sleep.
I mean, we said that every course that come up after one, we're going to do everything that comes up after before they're going to do it. So.
Cool.
That's nice when you have loads of people in your team, so you can
Four
shift and
four
swap.
people for 5 push courses.
Yeah.
How do you manage to bring 4 people on a vessel for 5 push courses? I don't know. Don't ask me.
I wish I had an assistant.
You can have.
I just have to ask around, and Teresa and Jessica, they're both in the room right now, really nicely help me with day. And Teresa, this morning I have 7 push calls incoming. I hope you might be around. Jessica
I will.
really loved sediment work. She loved it so much she's contemplating a PhD with Dr. Sediment.
Jessica is becoming a sediment specialist.
Jessica.
Against my will.
For sure, we'll be around. I'll be around until all the things that I need to sample will be sampled. And then at 6:30 I'll be up to treat the creatures and the sediment. So yeah, let's see.
So Teresa, why are you collecting the sediment? Because you want the creatures, did you explain already?
Yeah, I did in the beginning. You were not here.
But this was an hour and a half ago.
I did it in both languages.
Oh, cool.
You can do it now in your own language. I like to
I
hear.
don't think there's any Russian speakers online.
Just ask.
Amber here looks nice and cozy. She's getting to that point of the
Yeah, I'm
night. She's
actually
got
getting
nice
to
Very
the
rich. I think that one is going to get us in contact with a pretty big growler, so maybe we can move southeast for a little bit, get past that growler, and then come back north.
Yeah, that's fine. Do whatever you need.
Of course.
So there's a question in the chat asking us how long might it take sediment to build up. Now as Dr. Sediment, I can tell you.
To build up.
Yes, so as Dr. Sediment, I can tell you that it's very variable, which is why people actually study sediment in different places and sedimentation rates. So generally elsewhere in the open ocean, for example, ocean and like in the middle of the Pacific, far away from continents, it's very, very slow sediment rate, sedimentation, accumulation. Centimetres, 1,000 years, it can be even in some areas. You get more productive sedimentation sort of regimes. Essentially that sediment kind of comes off the slope of the continent and also is deposited by the rivers, all this terrigenous material, these massive outflows into the ocean. And in the place we are now, Antarctica, most of the sediment actually comes from icebergs as they melt. This glacier sort of moves. Just the rigorous that force of flow, it picks up all the sediment and rocks that are underneath as it moves. That kind of recirculates into its interior, and eventually when the stuff carves off and becomes icebergs, that will melt and redeposit all the sediment back in. Icebergs also have a very large kind of...
Like the 200, 135.
200, 135, Roger.
And they cause a lot of turbation, so sometimes this causes all the sediment to kind of mix up and flow and actually kind of fill up some of the topographic lows that we see in the bottom of the ocean. So in this area, essentially you get a lot of sediment fall out when the ice sheets retreat from a specific area and not much else, because we don't really have these continental shelves and rivers here where you can have nice sediment coming in. And there's actually people that called sedimentologists that study sediments, and some of those kind of mechanics behind how long it takes to accumulate, where the sediment comes from, what type of sediment is it.
We're not supposed to go too much far past the ball of the vessel. So right now, he's judging this.
No?
He's coming south and then he's going to come forward.
Okay. I think if we reach, no matter how you go, if you reach the plateau, you're in the good track, so. And we need to move anyway.
So right now we can't go any more forward.
Yeah.
Because we're
Okay, yeah.
So we just reaching 30.
Okay, thank you.
So I believe right now we've got some icebergs on our way, so we just have to wait. The captain is called the control room here, and is saying we have to wait whilst the ship above us, or we are currently on the ship, dodges these icebergs.
However, and to complement what my colleague was telling you about, in this case we would need a sediment trap so that we could actually measure how much the sediment will settle and when and in which rate. Isn't it?
Yeah, absolutely, we can do, yeah.
You can here? That
well,
would be so
on
cool.
the board, I don't know, maybe we should investigate for the
I don't
next
think-
dive.
I don't think
no,
you
I don't
have.
think we can, but generally you
No.
can, yes.
Yeah,
Another way
I
to
use
co-
it. I use it a lot for my things. And I use it for a year. and then each cup represents a month, and like that you measure the sediment, the
That is.
sedimentation rate, and I measure. So the geologist measures sedimentation rate, I measure the organic matter.
Perfect collaboration.
Yeah, I'm
So-
always with the geologist.
Indeed, even here, you've seemed to be befriended mainly the geologists. So another way, something we can do is when we recover these cores, for example, the push cores that we plan to get soon using the ROV, we could do something called lead-210 dating. So this is when we date how old the sediment is, and from that you sort of date it, slice up the sediment centimeter by centimeter, and you see how old this stuff is, and then you can work out the sedimentation rate essentially.
Also, it's another method then.
Well, and this is why one of my push cores is quite destructive, so you need a lot of sediment for this analysis.
Measure, yeah.
Like the amount of actual sediment you need. So one of the push cores is actually specifically for this analysis that I'm collecting.
Cool.
I think it's quite expensive because it's similar to radiocarbon in the sense that it's like a radioactive kind of decay stuff. Where there are some labs that do it. There's also quite a slow process. I have a colleague in the US that's been doing it with my sediments from the Amazon Sea, and she's got a lab that does this method, and it takes around 1 day per sample. So if you imagine if you have a push core of like 25 centimeters, normally you can, because this lead-210 has got quite a short half-life, so it's not the same as radiocarbon, so it'd only be normally 10 to 20 centimeters for the sediment that you can date until it's like undetectable anymore. But for if it was say 15 samples, that would be 15 like 2 days just to analyze one core.
Oh, wow.
So it's quite a slow sort of laboratory process.
Wow, yeah. But it's very useful information.
Indeed, I will get back to you if I've done it. Need to win some grants first to sponsor this.
I need to write a grant to process all the samples. So
Exactly.
join the club.
But this is what my push cores. So one of them I'm keeping as archive that I plan to do various analysis on, including non-destructive stuff like CT scan, XRF, it's like X-rays kind of, and X-ray fluorometry. So I need like a intact push core that's in the tube completely as we collect it, and then the other push core that I'm using for pore water. One pore push core I'm going to use for this lead-210 in the future, this sediment analysis or dating method, and one I'm staining for this rose bengal and keeping the lower part. More or less. Sometimes it varies depending on location, and I donate the push core if I don't find much foreign.
Collaboration.
Indeed. Yeah, it's quite interesting until I started working with my colleague in the US with this lead-210 stuff. I didn't realise quite how much sediment is required for this analysis, because a lot of the other things we do, especially Teresa is also a geochemist, so you know that we actually only need a very small amount of sample size for various parameters, whatever we want to measure, but for this lead-210 they really want a big chunk of sediment.
Phil will warn us, right?
ROV bridge.
Wow, we heard me.
Yeah, go ahead.
Hey, there's a little bit of ice cold in the building, though it's not particularly large. I don't know if you guys want to bring in the A-frame and just poke it with a stick to go away, or if you're happy to just ignore it.
Alright, let me go take a look at it, I'll get back to you.
Yeah, he said there's ice on the roof, that means the cable fell off, but just a little bit.
I think it's comes around more than like that.
almost.
So, Teresa, how many species of sea cucumbers have you so far sampled?
3, 4.
Or are you doing the same, still picking the same similar ones?
Yeah, the same.
Okay.
It's good.
Bridge RV, could you send one of you? Thank you.
Alright. So I mean, yeah, thing on them writing the offers they could ask.
And Amber, you were saying?
And I think the other one's gonna either be Sophia probably. I haven't really thought it out yet.
And you have to come to Portugal.
I've been 10 times last year.
10 times.
10 times?
In the last 2 years, yeah.
Wow.
Cool. No, you have to come more.
Yeah, but Ryanair got expensive.
Really?
Yeah.
Yeah, because you come from Bremen.
In the
Yeah.
first year, they flew from Bremen to Porto. Now they don't anymore, so I have to go to Hamburg, and it's way more expensive.
Oh yes, from Hamburg, yes, it is.
I've been to Bremen with Ryanair before as well, so they closed that whole terminal bit. Because they had that separate bit in the airport.
I think they really reduced the cities they're flying to from Bremen.
You can go, there is another way, because I've been in a meeting to Bremen. It was very expensive to go with Ryanair from Porto.
Yeah.
So I went to Eindhoven, and then I went by train. And it was really cheap
Okay.
to go from Porto to Eindhoven.
Okay.
And then you take the Dutch train all the way to Bremen.
How
And
long
it was
does it take? What do you think?
maybe 4 hours.
Okay.
Yeah. So
Yeah, sounds good.
I'm an expert on traveling.
clear of the growler and should be able to move in the desired direction again.
Okay,
Roger.
cool.
Once you bring your launch point, you could slow down a little on strap, right?
Yep, so.
Yeah. Once you could bring your launch point, you're gonna move the 3 points somewhere.
Or 8, no?
Should I just go due north for some time?
Yeah, Roger. You're gonna move to waypoint 8. So you're not gonna just go back to the line itself. You're gonna just move forward and go to waypoint 8.
Yep, go to waypoint 8 and you probably want me to do north of the line.
Roger. Or south. If you can't go north, you can stay south.
Yeah, north should be okay.
Okay.
Bridge already has the umbilical play of the ice there.
Yeah, like you said.
Yeah. No, we just have to move off. They have to dodge the iceberg now. There's an ice hooked on the umbilical.
So are you cool with us going this way, or you wanna come back here? And
No, go straight to.
Go straight to the
Yeah,
point?
yeah, it's good.
It's fine, I can do that.
Just at the waypoint 8 and be comfortable with it.
Bridge RV. Alright, updated waypoint there. We're heading straight to waypoint 8 from here, so you could make a beeline straight to your waypoint if possible.
Yeah, already done that.
Alright, thank you.
And we're moving at 0.4.
Copy.
Do you have I'd like to go for a cigarette.
No, here. Yeah, here.
So we had to navigate some icebergs, and I believe now we are just starting our journey back up the hill.
Up the hill sounds better than down the hill.
Especially if you don't have to do the hardcore climbing up your hill yourself.
Oh yeah. Oh, that's horrible. I was in Forest Alpine for 3 days. And it was amazing, but I suffered. To I don't know. I mean, I know that there's people who like to kind of, how do you say that? If you like to torture yourself a bit, and then when you climb, like you manage to climb up, and then you're at the top, and you're like, oh, it was so worth it. And I mean, it was worth it for the views, but oof.
I went there as well before the cruise, and it was quite tricky.
Especially with the backpack. For me, that was the hardest.
Oh yeah, no, we had a car. We were staying in Punta Natalis, so we just didn't have enough time for like hardcore backpacking and trekking. But it's very beautiful there, like I said. It's very good views, worth it.
It is totally.
Did you camp there?
Yeah.
In the actual national park?
Yeah.
Nice. It's very expensive.
I mean, the campsites, if you bring your own tent, is actually okay. We had a tent.
Did you have your own tent?
Yeah, that's why the backpack went so massive.
So is it on the ship now?
No, it's a medical tent.
Oh, okay.
I mean, I met him on the last cruise, and I borrowed his tent and brought it back.
Oh, that's perfect, because obviously we had to bring all this warm weather uniform with us on this cruise, because obviously we're in Antarctica.
You see the display.
So you were already full.
Yes, I definitely did not have space for any camping outfits and gear.
So the lighter part is the water.
Yep.
You look like you definitely need to go to bed.
I don't understand why, because I slept 8 or 9 hours.
What time did you get up today?
11.
Okay, that's quite nice.
I slept from 3 to 11. It's like a normal night.
Oh, like after, so you had a bit of chill out time after our shift yesterday. And
I had a big meal.
You had a big meal. This is what I'm talking about.
I
the
stacked
second
everything
and
on
third
top
dinners
that
of the
I
night.
found in the fridge. Yeah. It was like aubergine, no, how's it called? Eggplant sandwich with mayonnaise and ketchup. And
all the calories, like at this time of night as well, just eating all these strange, unhealthy foods.
You might have a zoom. Yeah, please. Yeah. It's a green
so
oil, I
did
think.
Sophia in the end refuse to give the talk
Thank
today?
you.
I don't know, I wasn't in the science meeting.
Also wasn't there, that's why I
Oh, no, because I had to extrude my cores because we thought the ROV was going to go down ASAP, and I was already like holding people up, but in the end, because of the ice situation, actually it was fine. But I was doing that, finishing that off during science meeting. So today I got woken up twice this morning, considering I went to bed at like 6 AM last night, which actually wasn't too bad because there's been days when I go to bed later. But first time my cabin mate came in at 11:30 maybe or something, saying that ROV is up or like about to come up. What do you want us to do with your sediment? So I told her to put it in the fridge and leave me alone.
Thank you.
And then she came in again at like 2:30. I was already awake, but I was not yet planning. Like I just woke up, I wasn't yet planning to jump up and go core extruding. And she was like, "Quickly, Sveta, people are waiting for you. You need to get extrude your cores. The ROV wants to go back down."
Who are you with?
Huh?
Who are you with on the carriage?
Laura.
Ah.
But she's my good friend. I've known her for like quite a few years. Anyway, but she was like, you need to do, and it was true because then I came out and then Sasha was phoning me and he was like, oh, but so this Sasha is co-chief scientist and also, I guess, the PI of my team that I'm here with, marine geology team. But he said that Patricia came up to him, who's the chief scientist of our cruise and PI of all the biology stuff, that she came up to him and was like, oh, we need Sveta's cores, like ROV people need them to mount them on so ROV can go back down again. So army style, I jumped right out of that top bunk, run to the mess, drunk some espresso, jumped straight into my workman outfit and went core extruding in the hangar with nice fresh air and some cigarettes to wake me up.
Huh.
The things we do for science.
Yeah, well, I mean, usually what I had in my past experiences is that you have like a team of 3 or 4 people, and they're able to do everything that is happening on board, and then you have them 12 hours shift, and then people are changing into another shift.
This is an ideal world.
Yeah, no, I'm just saying that normally the people should. I mean, of course, here it cannot happen because people are coming from different places and they don't know each other before, so it's kind of a different.
Oh, can you?
Situation.
Oh, it's disattached.
Yes, ideally I'd have
Yeah,
an
it's
assistant
okay.
or there'd also be a few people in my
It's okay.
team, like yours, so that, like you just said, half of you do course if it's this time, half of it do if it's like different time. But unfortunately, we just don't have that luxury in my team, so it's just me and too many scientific experiments. So then, yes.
And normally, what you have never happens. With Pedro, it always happens. He has always a big team, which is really good.
Yeah, it's
normally,
excellent.
I'm alone.
Yeah, but normally we also go with his company. So he sends us to take samples with 5 devices, and then it's just one team that he sends and the people know each other. Of course, I acknowledge that this is a totally different situation.
It's the ideal.
But you, Tony and Gina, you guys all knew each other before?
Yeah.
You're on the same program?
We've been to sea 3 times together.
Ah, so you've now got it all sorted out, like a well-oiled machine with your team.
Yeah.
It's nice.
Although this time it was different because we were kind of split, I was with 2 other colleagues on the first cruise. And it was interesting because if you take out 2 people of a team of 5, then you find yourself with different dynamics, which is kind of interesting. And also now it's with Gina and Tony, so normally we always have Fritz with us and another girl, she's also called Patricia.
So you normally have a bigger team, you mean?
Yeah. No, I was just saying 5 people who know each other and kind of work together, and then you take out 2 people and you have to find again a bit of your
I see,
dynamics.
like who does what and like all the tasks, yeah.
Correct.
Are you gonna go for a cigarette after our shift?
I will.
I am quite jealous of your cigarettes. So here on the ship we have a very nice smoking area. There's a very good view out of there. I quite like it. There's also this little bench where you can sit and just look at the sea as it passes by. It's very beautiful. I've even attached my GoPro there for a couple of nights for a time lapse. It's really nice that she gets because at this time, actually not this, well yeah, about this time, around 2 o'clock in the morning, the sun looks really beautiful depending on the kind of position of the ship. And then you get all the bergs flowing by, and I think because the smoking area is not too high up from the deck, unlike like the bridge or the heli deck, you get some like really good footage. Make some geological observations. Good evening. I have my new shift friends with loads of chocolate. So we're just doing some shift changes. I believe the science party and possibly also the pilots will swap over.
Yeah, I will stay more.
Ellen, come in.
Because my animals are not zooming.
Yes, there's rocks.
Push course at the top, as you said, the Niskin before.
No, what do you mean?
It's
Not all noted down. We took one. We collected one fish.
I
you
can.
can
give to the watch. Yeah, I will. Yeah.
You want me to tell you?
No, what's happening now?
We are
If
going.
there is something else that we are doing right now.
Get it. Okay. So we had to go down again because there was ice.
Yeah.
Then now we are going up again.
Going without waypoint.
Without waypoint.
Okay. So there is an example that we should collect because we.
No, right now it's transects.
Ah, okay.
Yeah, it's okay. But there is one thing here. We got some fish in rock box. So we cannot open this rock box because there's a fish in there, so it'll fly out. It's like inside the net, so we can't put more rocks in it.
Okay, no.
So this rock basket bottom has got fish inside the net.
Anything else notable?
They have the
Yeah, perfect. Yeah, I caught that when I was eating. Whatever meal I was eating. I like sweet corals. Hey everyone, we're just finishing up this science party change and pilot change. My name is Erin Easton. I am an assistant professor at the University of Texas, Rio Grande Valley, and I'm here with partial support from Ocean Census. This cruise is part of the Challenger 150 initiative. We are, I've lost track of how many dives we're at right now, but I think we're around 9 or so on the Climate Connections at the Sea Ice Interface cruise. We are still exploring this newly exposed area of the seabed. Today I think we started around 920 meters depth, and we're going to go up to around 580 meters depth. We're following a number of features. We recently had to run from some ice. Doing lots of escaping of ice the last couple of days. We're really close to the ice shelf, and so there's a lot of icebergs around. And yeah, so our team will be with you for the next couple of hours. Betta's still with us, and then we also have Anna and Maritza joining us. And right now we have Justin and Andy piloting with Justin flying. And yeah, Teresa's still in the room. We're going to be on the hunt for some holothurians here in a little bit after we get to our next waypoint. So that's our update for where we're at with the dive for anyone who's just came in. Oh, you do not want to hear me sing.
Were you watching from the lab, the previous talk?
I was just watching while I was eating upstairs. I had
As
no
Erin
sound on.
just said we have Professor Erin, Professor of Coral. We have Anna, Professor of Seawater. We have Reina Maritza.
Yep.
And I'm
Yeah.
Dr. Sediment. Me, I'm Dr. Sediment tonight, not Dr. Rock. No, I've upgraded to Dr. Sediment today.
And then two corals here. These are the three the same. This is a soft coral.
Okay, and what's in this one? Another
All of the same species from
Okay,
yesterday.
so there's 4 corals, all
Yeah,
yellow.
3 the same. This is soft. We also got it from yesterday. It's the
Oh.
same.
Like the mushroom coral?
Yeah.
Okay. Is it what color mushroom coral is it?
Pink.
It's a pink one, yeah. Okay, not a white one? Okay.
No, we didn't have.
Okay, like the mushroom or the one that inflates and deflates?
In pink, yeah.
The one that inflates and deflates? Yeah. It's the one that looks like a mushroom?
Yeah.
Okay.
I think it's
Okay. Perfect. Thanks.
You did catch a nice big fish, Erin.
Yeah, I did see that while I was eating.
Oh, you saw the big
yeah.
fish?
Yeah, I was
That's
up there
quite
in the
big
mess with Tom. We were watching the action. Very smoothly done.
It was very nice. I was telling everyone earlier, I was just waiting for you guys to arrive. It's chocolate. We got to that point of the night. Because I really want my third dinner, but I've got another 2 hours until I can have the third dinner. So maybe it's time for my 4th espresso.
Yeah, I had espresso just now for the first time on this expedition.
Oh no, I've got espresso machine for extra strong espresso in my room. And actually, because my cabin mate wanted to go to sleep like a few hours ago, I made 2 double espressos before she did in preparation for the.
ROV bridge, you guys happy with the speed, or would you like us to slow down a little bit?
Yeah, we have a number of encrusting sponges, some crinoids on that wall there. It looks like we're good to slow down a little bit. So we're going to do that so we can get a little better look at some of the fauna that we're passing. Looks like they collected a rock at 853 meters, so are we due to collect a rock, Saveta?
Yes, the kind of rock we want those. I think you guys, Jess and Andy, collected it yesterday. It was like the kind of whitish one, pinkish one with dots, because it's different. We're thinking it might be like a volcanic rock, and we're actually really interested, so it's really different from the metamorphic black rocks that have been collected so far. And Professor Rock, who's on the ship, was extremely happy with our rock collection last night, so which is why today I'm Dr. Sediment.
For that reason,
You promoted. We'll keep our eyes peeled for a rock that looks different.
The kind of pinky white type rocks are ideal.
Yeah, we were telling Andres that it was just looked like it was sitting there perfect for us, balanced on another rock or rock outcrop, just like here I am. I'm different, choose me.
Exactly. It was quite fun. We got the rock saw out today and did we have some nicely smooth sawed rocks now.
Nice, yeah. That's like a new addition to the ship, the rock saw. They didn't have that last year. I kept hearing it was on the way.
It was quite loud and it was quite nice on deck, a rock saw. Get all that stress out, just saw some rocks.
I want to see this rock saw in action.
It was on the sink next to my toilet brush, which I use for cleaning my sediment.
That's what you were searching for.
Did you find it
It's
finally?
the most popular item on the ship. So when I bought it in Chile, quite a few people that were from my team thought it was extremely funny that I was buying a toilet brush. Little did they know, everyone is now jealous of the toilet brush. And yes, it is new, brand new, just for sediment core cleaning. I did not steal this on the way from the airport.
We see what that is. I think it's a sponge, but...
Where was your toilet brush?
Where? Oh, it was left outside in the sink. Outrageous. So someone borrowed it whilst I was asleep from my laboratory bucket full of other hammers and screwdrivers and necessary items, and did not return my toilet brush.
We can still give that a quick little zoom and see what's there. It has a nice little community around it. Sea stars. Some brachiopods. One of these sponges that we've seen quite abundantly. Some shrimps. A couple of sea
I can do a lot of talking,
stars.
but I'm not very good at singing. So that will have to be Reina Maritza, but Professor Seawater, and maybe Professor Sea Cucumber.
I think our instructions are to not sing.
Exactly.
Well, I'm saying I shall definitely not be singing.
Yeah,
so
me
you guys
me
can have
either.
a choir going. I'll be the conductor.
That's good, thank you. You do not want to hear me sing. It's like a joke in my family that we're horrible singers.
Same, me too.
Yeah. But my dad insists upon singing happy birthday, like 2 verses for everyone's birthday, like it's a whole ritual. So, so yeah, it's like really off key, like singing for everyone's birthday. It's horrible and awesome at the same time.
Aaron.
Mm-hmm.
7 push cores tonight.
We still need to get the fish course?
I'm going to waterfying now. Sediment. Dr. Sediment wants sediment today, not rocks. No, but Matt said I could have his push cores, so just if we do end up doing them soon, basically I need like 7 really full, so 2 long ones like standard and then 5 short ones like full of sediment with less water. So the ones that normally go to Matt are going to me plus all my normal ones.
Okay. It seems like they have push core sampling area is in at waypoint 9 apparently. Okay. I think we're not quite to 8 yet.
That's an important update, so thank you for passing that on. I would have eventually have seen it when I read.
Oh no, but it's not on there because Sophia was asleep with the push cores. Like when Matt said I could have his push cores.
Oh yeah, well that part, yeah. So, that's lovely. Are we giving you an extra 8, 7? How many push cores does he have?
He gave me extra 3, so now
Extra
I have
3.
7 in total.
Okay.
So that's going to be a fun morning for me to process my sediment.
Yeah.
How many strong
Want
minds
these?
need?
Not yet? Okay.
Quite a few. 7. What? Push core.
Oh, there are some people that definitely do karaoke, but yeah, they have like a whole karaoke machine. To each their own, I say. I do not partake in karaoke.
What, on the ship?
Yeah. Yeah, there's a karaoke machine up in the backyard. At least that's the last time I knew where it was.
Okay.
Yeah, this is really nice.
I agree.
A
This
lot
is an extremely
of-
beautiful rock with biological Christmas tree decorations.
It is. There's an anthomastus coral there. We have some worm tubes, sponges, shrimps, because there's always shrimps. So, you took a sample of that, but a pink one?
Yes.
Okay, perfect.
You can take another one because it was quite far from here.
No, it's okay. Like, I'll wait. I've been looking for the red one to get. Was it red or like a pink?
No, sorry. It was pink. It was not this one.
Okay, perfect.
No, it was the pink.
Awesome. Yeah, that's the one that we haven't been able to get the last few days. So, thank you. Just want to make sure.
You're a real coral
Awesome,
specialist.
thanks.
They search for body caves, also for the request and mollusk.
Yep.
Just have another.
Yeah, that's
I
the
will.
same. Yeah, that's the same stuff we're always looking for. Thank you.
Are you guys happy with the space, or you want us to kick it off?
No, we're good. We have like we have an hour to get to waypoint 8, and we're going considerably faster, I think, to get there. So yeah, this pace is good. Gives us a nice view.
An hour? Oh, thanks.
Yeah, so we have time. I don't know exactly how long they were taking. I can see the jaunt around the iceberg.
Yeah. Iceberg dodging is very interesting. I'm curious how this side doesn't have as much like corals on it.
Yeah, well, I suspect, so the current looks like it's coming from, I have no clue what our orientation is right now, but from the right side or kind of a little forward. So I'm guessing that if we were on a slightly different side of the feature, we might see more exposed rocky walls with less sediment. We might see more corals.
I think it's only just finished, like the rocky coral bit, just before you guys like came in. I had loads earlier.
Okay. Yeah, when I woke up at 1, I wasn't seeing much, so.
You wake up at 1?
Well, actually, I would
to
say,
bed?
I actually never went to sleep. I just finally decided at 1 I should just get up since my shift started at 2 and I was starting to get hungry. So.
Oh, yeah, we were just all discussing the amount of 3rd and 4th dinners in the earlier shift as well.
Yeah, like I can't even tell you how many times I ate today. If I had 3 meals or 4 meals. I think there's a like light snack in there somewhere.
We can decide to go dinner at first dinner, second dinner, breakfast. I will
Oh, thanks to
breakfast.
whoever has picked up on my name in the chat. That's quite nice. Probably all the late night commentating.
Let's see if we find something.
Oh, look at that go. All these sea cucumbers are very like, I don't know, like at attention here. They're all kind of like arched up. I'm not used to seeing them all like that.
Propped at the ready.
Yep.
There are many compared to the previous spots.
Actually, there's quite a few now.
I know, but you cannot do the here.
Yeah, yeah.
That's much more.
Have to go a little bit further higher up.
Yeah. You can do it.
That guy's a little bit
This is fruit, is not.
Gonna open my coffee cup so you can all smell the coffee and be jealous of the espresso. I'll have some if you want. You want some? No?
No, I'm addicted to coffee, but I don't stop taking
Benthic jelly
Well, I
floating
have
through.
coffee machines, so I think that says something. Essential purchase list and shitty espresso machine.
What do you do with it?
I just think it's funny you bought an espresso machine. There is like probably more espresso machines and coffee machines on this ship than like
people.
No, I didn't know about that. But also, I have like proper strong coffee because the one in the mess kind of tastes like coffee juice, you know. And I need like for this crazy night shift life, like some espresso.
I think they have some of those. I mean, all power to you, but I think they have some of those too. I mean, I think the MTs have like a couple.
Oh yeah, but I didn't know
in there.
people did.
Yeah,
So
no.
I'm just gonna donate mine as well to the ship.
Donate to them.
There you
Oh, I
go.
will do because I'm not gonna take this coffee machine back to England. Probably cost more to pay for extra luggage than the coffee machine.
I think
in
this is
the
a
first place.
Branchioserianthid that we're seeing right here.
Oh, look at. Oh, and that one. Oh, look at this one. It's so big.
I think they're called branchioserianthids. These, yeah, we can give a nice glamour shot to that. I don't know how many of these they have seen on the dive so far. I know we've seen a few throughout the expedition, but this is a pretty good
We
sized
haven't
one.
actually in my previous ship we didn't see any, but I think we were mainly going right against that rock wall, so Anna, are we still doing a whiskey bottle before the push goes?
Yes, of course. It's written. It's not written here. I put the notes there.
Plus it's now
And now it's written also there.
I'll probably be during our shift as well. So.
I will communicate.
Yeah, we can go ahead and continue.
Saquito, but I don't know where.
Who's using
Yeah.
Saquito?
For
Yeah.
America.
Okay.
The sediment in this area has been quite easily disturbed.
Okay, as
Point
the
we are
jellyfish.
now.
Oh, it's gone.
7. I cannot read it.
We're between 7 and 8. We're a little over. We're most of the way to waypoint 8 right now.
So where do we? There is also Saquito that we need to do on.
Yeah,
the white blue spot.
Yeah, I've read the. I got it. Thank you. There. Right at the top here. Look at all the sea cucumbers.
Oh, look. How many?
Little sea urchin there. Another branchioserianthid. Getting up closer to the top, but you can still see the current is coming in from the one side. There's some anthomastus though facing the current as we're passing over them.
So for anyone else who's just joined, we're currently in the sub-ice shelf conditions, essentially, that this area was completely covered by ice only around a week ago. We were very lucky, we were in the area sampling already, just around the corner. So the iceberg carved off and moved away very quickly, so we were able to access the area. We're now exploring the seafloor, so it's very interesting. We're finding lots of very interesting new things. And this is also why there's a lot of rocks exposed in this area and not too much sediment.
Do you think it's feasible to do push course here, 3 for me?
Yeah. Do you want to do all the collections here in the push course? Yeah, we can test it.
Yeah, if it's possible, then I leave you alone.
Yeah, that's fine. Yeah, can we go and sit
Ready,
down?
Joey, can we pause the move, please?
Positive.
There are more puns. The more time I spend on the ship, the more of the crew I find like puns. Yeah, let's.
I think there's still too many rocks here. I'm not sure how much.
I'm sorry. Okay, just was asking you about the sea cucumbers because this work is to be done with these ones, really gentle.
Okay.
And then the push cores, the ones that I use, were given to me. It's number 1, 2, and 4.
Okay, 1, 2, and 4 are your.
Yeah.
Okay.
Because number 3 is for Svetlana.
Okay, perfect. 1, 2, and 4, and then we can suction up the holothurians, but gentle. Okay, perfect. Thanks. All right. Do you want us to do the push cores first to make sure it's good?
Yeah.
Before we try the. Okay. Perfect. All right. Thank you. All right. Yeah, we'll go ahead and do the push cores first to make sure we can get them before we try sampling the holothurians. So it's 1, 2, and 4. Yep.
I'm going to have a long morning today with my 7 push cores.
Do you have the specific number or 3?
Normally I have, there's 3 long ones for geology, so for me 1 found dress and the rest like,
Okay.
but I just need them like full of sediment, the less water the better.
We know. We like it.
I know, it's just but yes, so normally I process 4 push cores that we were discussing earlier in the shift, and for anyone that's recently joined, I use 1 for archive. So I want to do some non-destructive analysis on this, such as CT scans, XREV, which is X-ray fluorimetry.
Yeah, that looks good.
And physical properties and other analysis, and keep it for an archive core.
Water left in this?
Yeah, water left in these.
Yeah.
How much?
It's fine,
That's
it's
good
okay.
right there. Yep.
Another push core I use for pore water experiments. So this is when I extract pore water using some syringes out of the push cores. So I can test the chemistry of the water sample against the things I'm finding these foraminifera, the shells that I'm interested in, that live in the sediment. Another core I use for foraminifera staining experiments, and then the 4th one is for this lead-210 kind of dating analysis of the sediment for work out sedimentation rates and things like this, and also how old these foraminifera were in the layers. Today I want these extra push cores because one of our colleagues on board said that he doesn't need them from today's dive.
Wow, that is amazing.
I know, yeah. So then I get 3 extra push cores, but the problem is ROV is coming up at 6:30 our time, and I think everyone wants to get it to go back at 9 a.m., which means I have a very hardcore morning of extruding 7 push cores and processing them. Yes, please. I need all the help on board, especially because my normal helpers, half of them are asleep. I did try to offer rocks and coffee for help for push core extruding, and cigarettes, but people weren't having it. I brought 1 kilogram of tobacco with me to see if I could exchange that for.
You should have brought 1 kilogram or more of chocolate. You might get a few more takers.
Tobacco is more important. Actually, no, you'd be surprised. Tobacco has been very popular so far, so it's a good shout.
You guys got your photos, right? We're good to take these.
Yeah, we're good to take them.
Do you want photos of the 3?
Do you want any photos of your course? No, we're good. Nope.
Yeah, we took that.
I didn't think so. I just thought I'd double check.
I know. I got here.
Yeah.
Erin, I hate to upset you, but I had to log Tom's fish as a rock.
I think that's more upsetting to
For the
Tom.
reason that because we put this fish in the rock basket, there was actually no location for biological sample to go in the rock basket. So I did log it in the wrong box, but then I logged it again, so it's in the right location as a rock. And in notes I did put a fishy fish for Professor Tom.
Well, I think that's more of a problem for Sophia than for me.
But Erin seems to get very upset when I log things as a rock, when actually it's meant to be a coral.
That's for sure.
When it's a, yeah. It's, well,
that was
when
not me actually, that one. That was someone else.
You know that we own collect.
it does make it complicated to search for your samples. If it's logged as a rock and not as a coral.
Me who logged the coral as a rock.
Don't worry, it's all
My supervisor.
it's all documented.
My supervisor called my solitary coral as a rock. Like, really?
I think it was on the first day, there was one of the other geologists, and he was very confused by saying that he thought that we were sampling a rock. Turns out the actual sample of interest was the coral that was happened to be attached to the rock, not the rock.
Yeah, there's nothing like searching for a coral sample and
And find out.
and not finding it because it says it's a rock. A little misidentification there.
This is why it's fun on a multidisciplinary cruise.
Thank you. Yeah.
You're in order.
Nice job. It's always bonus. We're gonna, yeah, we can suction the sea cucumbers into, yeah, 7's fine. We're on 7, so we can do 7, and we want to do gentle suction.
Well, they're not gonna run away.
Yes,
so-
we've
No.
not done our push course yet. We've actually only just done the first 3 for Professor Sea Cucumber, who's about to now collect her sea cucumbers.
Because once it goes, it's gonna be the jar.
Yeah, it makes turbulent. Yeah, I think once it's in there, it's fine. So we'll want 3 total.
Okay.
Just kind of the suction we need to get it from the sediment to the jar.
We came to the wrong ship.
Dr. Sediment.
But calling a coral a rock is less weird than putting 2 corals in the same container. So at least there was a rock attached to the coral, so I can understand the confusion.
This is actually everyone in this room has not helped me yet with my sediment extrusion. This morning.
You know, it takes us longer to process the corals.
Process hours.
You guys are usually done with everyone's usually done slicing their cores before we finish with the coral
No one
samples.
slices them apart from me, and that's actually quite tedious at the time of the semen task, which is why I'm always looking for helpers on the go. Are we doing them in the same sucker?
Yes, we are.
open them.
Wow.
And 680 meters. There goes number 2. It was all 3. I missed the 3rd one while I was jotting down the notes. Thanks.
Okay.
I'll see you
I can
in a
see
few
two.
hours' time. Maybe you can even have a fresh espresso.
There's 3.
Yeah.
There we go.
Great. Thank you. Good night.
Perfect. And then, yep, you're welcome. All right, yeah, get some good rest. Thank you.
Good night.
Night. Yeah, I guess we can index to 6.
There is a question for you.
Question?
The age of your rock.
So we actually don't know how old these rocks are yet, so we can do things like argon-argon rock dating. This tends to be quite an expensive method to date rocks, but that is one of the things we want to do. There's 2 types of rocks that we've primarily found in this area so far. We found some metamorphic rocks.
Yeah, I have something in 4
I'll continue in a second.
and 7.
Nothing in 5.
Yeah, I don't think so. It's a little unclear if that's in 4 or 5. Do you have anything in 5?
No, 5 no.
Okay.
I have
Yep.
4.
We're just 4 and 7.
On a sponge.
Something in 4?
Yeah, we have
4,
something
yes.
in 4 and something in 7.
And 5.
Yeah. It does say. Can we look at? Why don't we? Can we look at 5?
Because I don't have anything here in my notes.
It certainly looks like they tried.
Oh,
Oh, there's
yeah,
a fish in
there's a
there. Yep.
fish.
All right, let's go.
So
There's something in 4. All right, we can stay on 3. We can stay indexed 2 or 2 wherever. Okay. Yep. I'll.
Yeah, 3's medium mesh.
Okay. They have something written here, fish, but they didn't have an arrow pointing to which one, so I couldn't tell if it was 4 or 5. But okay, good.
Alright, anything else you guys want to hear?
Uh,
I gave this rock there.
This rock?
Yeah. Is this rock?
Do you want this rock? I think we'd quite like this rock.
Okay.
I quite like this rock.
Yeah, so we can go ahead and take that rock
But
and.
maybe after this one, if we just need to look out Erin like the one we had yesterday, those white pinky kind of rocks, that's very interesting.
Yeah, I've been looking. This one's a little lighter in color, so it also seems kind of interesting.
Yeah, it's got some overgrowth in it, so we'll see. But
Okay.
basically, this type of rock that we're sampling right now, for those asking in the chat, so this is what we think are some metamorphic rocks. So they're
We can
probably
put it. It looks
schists
like
and
they've been
metal
putting the rocks in
sandstones.
2B. So yeah. Or I guess they're putting some in that. You haven't taken the bags out yet, have you? So yeah, let's just put it in 2B.
Yeah.
Sorry, it was indecisive.
So these rocks are probably schist and metal sandstones, which means that these sandstones essentially originally are sedimentary type of rock. However, because it's been so many years and from the high pressure system and more rock accumulates on top, eventually on sort of hundreds, thousands to millions years timescales, these things accumulate and turn into a metamorphic type of rock. Regarding the age that we think they might be,
We can get a quick
Jurassic
glamour shot on it.
potentially, maybe 150 million years or so.
Make sure they can
Let
tell
me
them
just,
apart later.
sample this. Yes, thank you for the shots of my beautiful specimen. But some sediment for Dr. Sediment, and the rock can go to Professor Rock. He'll be happy.
Andres probably.
Yes, that's Andres.
This is going into 2B.
Yes, 2B. And 2B or not to be?
Back out the bottom. So if you want to come off, just come off. Hover.
Okay, I'll see if there's any play right now that I've not.
It's 2B. Those sliders are proportional.
They are.
Yep. Alright, so camera.
Nothing's good.
To Bravo.
I've just noticed the to be or not to be sticker.
Yeah.
I've just noticed that it's like third night shift I've done in a row, and who knows?
We put how many rocks in Biobox 2 last night?
I was too into the rocks yesterday. Just who put that sticker on there? That's very funny.
And this will rock. You should put the coral for a while.
Yeah.
Be or not to be coral or rock.
I think it showed up in the middle of last year sometime. Early last year, I don't know.
Thank you for the rock.
You're welcome. Alright.
Parallel to the course line.
You know, we keep seeing these two corals right by each other, which is interesting.
Yeah. Sounds
One
good.
likes to be smaller, one in front of the other. But that's a Brazingid sea star there. Alright.
I'll move the waypoint up.
But yeah, so as this ice sheet kind of moves and flows, essentially it moves a bit like a liquid in a similar type of fashion. So just from the sheer strength of this thing moving, it rips off rocks and sediments that's underneath it, and then that gets entrained into the interior of the glacier as it kind of moves and folds.
Can we take
And
a look at
eventually,
that
when
fish?
the ice sheets collapse as icebergs, they'll spit out these drop stones out of the ice sheet, and this is where we think that igneous rock came from. So kind of evidence of Antarctic volcano. And if we take that rock that we found last night, this igneous one, then we think we'll be able to tell how old maybe some of these volcanic eruptions are, which is very interesting. This is similar to the big fish we sampled for Professor Tom earlier, the one that's in the rock box. I know, it was very kind of sneaky, and then we tried to put it in the bio box, but it kept kind of escaping and we couldn't put the net in the bio box, so then we just stuffed it in the rock box together with the net.
So now we have
Yeah, that's good. You can go ahead and keep moving up.
But I locked at this boat to keep everyone happy.
Just get some
Make
nice
sure
ones.
Erin doesn't get very upset with me.
Why would I do that?
We're still talking about the fish that's a rock. Oh, the Professor Tom says this is a different one, but they all look like alike. Professor Tom, would you like us? Oh, it's too late. We've gone past it. Offer
too
to
late.
sample the challenge to sample the fish.
You said that it was different.
Tom is feeling very fishy today, so he's on a mission to sample, go underwater fishing.
Okay, we will try to get the next one, Tom. You said that it was a different one, but it looks very similar.
And he also says he's very happy already because we've got him 2 fish.
Yeah. Well, that's why we also do the nice zooms, so that even if we don't collect it for him, he can ID it. Either while watching or later.
Oh, look at
If you don't do the nice zooms, you can't tell them apart.
That looks quite different to the other ones we've been searching. The other ones are kind of like hollow and like to set things in.
Nice
like
little cup coral next to it.
That sounds onomatopoeia.
Exactly, perfect.
But this is interesting.
This one looks like a kind of an actual sponge that I use for my like washing up, stuck to the rock.
Little
And I
polychaete
lock the rock.
there.
There is a polychaete? There is a polychaete there on the sponges? You see it?
I love them.
It's lively.
Yeah, it's the type of sponge I use.
Another saranthid there. Tube worm. Yeah, so we're nearing the top of this feature. You know, we're seeing a lot of the stones look very similar but different from the underlying bedrock here. They're kind of that grayish color, grayish blue. What about, can you actually look at that rock right there? That might be one of the magic rocks we wanna, it looks kind of pink to me.
Yeah, this one.
Yeah.
And this one? It's not
No,
different.
we don't want the grey one, but this pink one.
Yeah,
looks
can we
quite
collect that pink
attractive.
one?
Yeah, do it.
Thank you.
Yeah, no worries.
Told you I'd be on the lookout.
Professor Rock will be very happy this morning when he wakes up to help me with core extruding. Maybe I should say I'll exchange the rock if you extrude these 7 cores for me. Ballet, quickly.
Great job. You can pause a minute. I think you're going to have to come this way.
Stopping.
So like I was saying earlier, these pink kind of looking rocks, so we think they're joke stones of igneous nature, so probably from a volcano. And these would be actually worth investing the money on argon dating and seeing how old they are and how old these volcanic eruptions were in Antarctica. And also potentially that might help us identify the source of exactly which volcano, because actually there's a lot of volcanoes both in Antarctica and in the seas around it.
2B? Yes, and 2B again. We'll do a glamour shot.
Get a nice shot, sis, please. Such a beautiful rock. Perfect for my rock collection. Oh, wait, zoom in. Nice. Thank you. That is very nice.
Nice, yeah. Zach is gonna be so jealous with all these rocks.
Oh, really?
Oh yeah, you need to talk to Zach. He makes
He's only ever awake when I'm asleep.
Oh, well. Catch him at dinner. Have him show you some of the jewelry he's made with some rocks. Yeah.
I'll have to chat with them. So that's in the BB.
BB2B.
Not to be a rock for a while.
Yeah, he's super excited about the rock saw. Like, it's one of the first things he told me when I came back on the ship. You know, we have the rock saw now.
That is cool. I'll chat to them. Rocks are actually very interesting. You might think they're this dead piece of rock, but actually a rock can tell you quite a lot of information. So all the different kind of dots. So
Alright, thank you very much.
All the kind of dots on them and these intrusions, the incursions. They're kind of like a window into the past and the history of our planet, especially on these longer term geological timescales and kind of how tectonics and continents formed, which then affects things like ocean circulation, atmospheric circulations, which are actually very important because they redistribute heat around our planet, most of which just hits the equator, comes in, and you need these circulations around the planet to redistribute that and make conditions livable for biological life, but obviously of course humans. And rocks can help us answer a lot of these questions. They look quite boring, but they're actually very interesting.
On the move again.
One thing we can do, and we do in geology, is we make a slide of rock under a microscope, and then we examine these rock slides under the microscope, and actually they look really cool. They kind of look like a kaleidoscope, and this is partially due to the spectrological microscope. It's got these kind of dual vision mechanism, so you can kind of do reflection from different arrow and send these lights through different crystals, and depending on the crystal orientation, it's actually super beautiful. These thin sections, it's called, this kind of slice of a rock. You guys, if anyone's interested in the rock conversation, should Google rock thin section. I promise you will not be disappointed. It might open up the new world into the rock.
And become Dr. Rock.
Sometimes when I'm teaching, I give a student a rock and I tell them, talk to me about this rock. And then we just keep going for an hour until the class ends. So they'd be quite surprised normally, the student, by the end of the class, of how interesting the rock is.
You know, when I was undergrad, I was a student worker at the Geology library.
Oh yeah?
Oh yeah. Yeah, and I took a basic geology course too, where we got to I learned a little bit about rocks.
So you were a secret rock fan.
Yeah, and maps too. We had like a repository of, we had to hold one map of every map printed for the like USGS survey. Yeah. Interacted with a lot of geologists for my entire 4 years, and
undergrad.
Then you're like, I'm going to biology.
Well, I also, I always,
That's why I
yeah,
left.
nothing.
The rock thing just did it.
I took an astronomy course. I took lots of science
That
courses,
is cool.
but
It's interesting, like in the US, you guys can take all these courses and kind of find your way. I think it's a better system than in Europe, where we have to kind of specialize, like from a really young age, and then often it's very hit and miss. Because, you know, for me, she did an economics degree, and then I was going to become a banker, and then something went severely wrong. Yeah, exactly. Something went severely wrong, and then I became a geochemist. I'm not joking. So my bachelor's degree is in economics.
Can you imagine Smita in the bank behind
Hey, I
the
wear a
desk?
suit.
You can. But
Yeah.
Of course you can. But just imagine you and open a client and say, I'd like to open a bank account. Are you sure?
Let me tell you about this rock, and then we can discuss the finances after.
oh, there's a nice group of mushroom corals there. If we can get a nice view of that. We're not going to collect or anything, just kind of get a nice view of this little cluster.
I'll just fly over this colony here. There's these two.
There's like, I think 2 more off to the right. 1 there. Yeah, 1 up. Some shrimps. Everywhere shrimps. 5 of them. The corals. Nice. Just get some beautiful shots there. Some brachiopods. All right, perfect. Thanks.
It's interesting that actually almost at the top of this hill. I was expecting there to be a bit more sediment at the top, but we seem to still have a lot of exposed bedrock.
I know. We'll have to see how the coring goes. If we can find
I shall
somewhere.
not be deploying gravity core in this location.
No, definitely not.
A little bit risky, huh?
Oh yeah.
Some nice.
Not recommend.
Oh yeah, let's zoom in on that fish. Yeah. Maybe do a pause. I think this was one that he.
Professor Tom, would
2
you like
different.
this fish?
There's 2 different. These are definitely different species. Don't know what they are. I think the one right there is amazing. Yeah, this one that didn't run away.
Oh, I've
That
just
is
spotted it.
different.
I thought it was a piece of rock.
Well camouflaged.
I did see the other one that was swimming around.
You guys don't want that, do you?
I haven't heard from him, and
No.
oop, it just swam away.
He's
So
typing.
Oh, he's typing.
Maybe.
It's the challenge of the day to collect the fish. Oh no, he doesn't want this one.
No.
yeah,
Doesn't want us to get shut up.
yeah.
Next
Just
challenge.
loads of them.
So someone was asking us if the shells are occupied or long dead.
Yeah. So So this one that you're seeing that's really shiny on the left, we can actually zoom in on it. This one's alive. Most of the others we've been seeing are dead. So the ones that are alive are usually one you can still see both the shells, the top and the bottom, and they tend to be brighter, and you can see actually the tissue inside that white circle. So if they're dead, you're not going to see that. That's all right. We can keep going. Hopefully they caught enough of that. So yeah, you can see it's kind of reflecting back the tissue in the center, in that part. Some have been more like kind of white, and others have had this rose tinge. I don't know if those are different species or not. But yeah, you can see the dead ones largely have a lot of sediment on them and are more of a cream colored often. So yeah, it's kind of how you can tell if they're alive or dead as we're going through. So anytime you see that bright kind of iridescent, almost glowing back at you, reflecting back at you, that's probably a living scallop.
Professor Tom, there's a fish on the horizon.
Yeah. I think these are the ones that pretend to be tripods, but they're not. But I don't know what they're called.
ROV Bridge, do you want us to slow down a bit?
This one is an ice fish, says the professor.
And I'm not really sure if we've already collected a lot of these scallops, so I'm right now thinking that they don't need more. If they do, there's some time left in the dive later.
Too much life.
No.
There's a beautiful rock upcoming on the horizon.
Small fish down there. This is one, I think that was just nestled up against the rock earlier. Like, not the same one, but the same species or similar.
Professor Tom says he suggests a new nickname, bipod fish, rather than a tripod fish.
It's a joke, only biologists. Maybe not only.
A nice cup coral there. I think you guys can start putting together your own like pun and dad joke calendar. Just write down all the jokes all the scientists and the crew are saying, and then
My
submit
favorite
them.
was the maths book one. What does one maths book say to another? I have so many problems. Dum-dum-dum.
Oh my goodness. Oh, look at the fish on the front.
Yeah, that's a cute picture. Actually, can we turn the lasers off for a second and get a few seconds of view of this? See if the sediment stays out of the way. Okay. That's alright. Fish is moving. Alright, we can go ahead and pop the lasers back on and continue. Just thought that was an interesting shot that might be nice.
For sure. Who did that?
It's the scallop's fault. That's it. Blame it on the poor innocent mollusk.
I'm gonna buy us some time here in a second. Is there
It looks like we're past waypoint 8, so we should.
Is this video transit to the next one? Is that
Yeah,
what I wanna
this
say?
is where we should start. Go ahead and transiting for a while.
leave it, I assume there. I'll fly to this bunch. See if there's anyone home.
It's a nice sea urchin underneath the sponge.
Mm-hmm.
To the left of it now.
Yeah, I think there's a type of worm. I think it's been an arrow worm that's been making a lot that we've seen has made a lot of the spiral sediments. No, we're okay. Yeah, let's go ahead and transect for a little bit. We're supposed to be transecting here. Yeah, I really like these sponges too. I like the color of them. They're not, a lot of times you see the glass sponges are that bright white color, and the fact that these are kind of a rosy color are kind of nice.
For transect, do you want me to maintain a certain heading and 1 meter off the ground kind of thing?
Yeah, let's go, yeah.
200 meters of transect?
Yeah, largely unless we see something really interesting until we get to waypoint 9. Let's go ahead and maintain transect position for however long this is.
It'd be interesting to see what the sediments are like from here, because the previous dives from this new sub-ice sheet area have been like very deep, so the sediments are very kind of clay, full of clays, very stuck together. And then actually the ones from this morning's dive did have some sand, so I'm expecting here it'll be much more kind of coarse grained and sandy.
Mhm.
might change my things to actually get more seafloor.
Okay, perfect. Sounds good. So you're saying that this is what our fourth dive in the under the sea ice, but you're saying our first two were very fine clay-like, but
Yeah, they
the
were
last
like
one was
face mask
sandy.
material.
Okay.
And then the third one had a bit more sand, although I think that was still fairly deep, right? Do you know what depth we got the push course? Like when I was from when I was asleep this morning, so I'm not sure.
Yeah.
600? Oh, so this is actually similar, so that makes
Yeah.
sense, the shallow ones being more coarse grained.
Yeah, and I think too, like we're seeing something very similar today to what we saw yesterday during our shift, and we actually see a lot more biogenic material, like visible biogenic material in the sediments.
Although I did not see that in the actual sediments, in the push cores.
Yeah, I don't know where they took them.
They were still fairly like sandy and just uniform, because there was one side from, before the SOI area, like a while ago, at the beginning of our diving, that had like this layer that was actually like orangey fluff layer you could see on top of the push cores, and it was really smelly when you opened them up.
Mhm.
So that did not happen from the ones we got this morning.
Yeah, it's kind of a shame that we're just getting, and not so much that we're getting one set of push cores, but that it's not that we're not getting like a series of push cores. Like so many people need push cores that we only get it in one area per dive.
I know, I did actually originally want to suggest that they sample me all the push cores at different locations so that it's like a depth transect, but then because there's so many complications and people want so many different things,
Yeah.
I've just decided not to complicate things.
Yeah, I mean it's like that balance of needing your replicates versus meeting the needs of everyone on board, and then the limited number of cores that can fit on the porch.
But I've been fairly happy because we do like quite a few dives, at each location. So
Mhm.
actually, I still do get like push cores from different sides.
Yeah. Look at that line of scallops right there.
Some more sea cucumbers.
And scallops.
Mhm.
All right, no Maritza.
Nice
Will you
little
be going to bed after
anthomastus.
this shift? Going to sleep
Yeah.
after? No? And are you
waiting
going to
for
sleep? So I think the ROV is right now it's 3 o'clock in the morning for us approximately. The ROV is meant to come up at around 6:30. So I think all of us on this shift will finish in about an hour at 4 o'clock. And I think unfortunately it's going to be another long all-nighter for us.
Yeah. Yeah, because the ROV comes up only like 2.5 hours after the end of our shift, so you don't really have time to sleep. You gotta transfer the information from the annotation system to a spreadsheet. We have to make labels in preparation, and then we have to take the time to process the samples before we get to go to sleep. And then we get to wake up to do it again at 2 o'clock in the afternoon.
I see, I'm lucky my sediment is not urgent, so because there's no other dive after 2 o'clock for a while, because we'll be doing some mapping and getting a rest tomorrow night, I'm just going to ask people to put all my cores in the fridge from the afternoon dive and get some sleep.
Yeah.
Because I suspect I might be going to bed at like 10 o'clock this morning or something. That's like next level night shift, latest.
Yeah, I think we're hoping we can go to sleep around 8 and then probably wake up around lunchtime, maybe just after, and then scrounge some leftovers. And then I have a meeting at 1, I think. Yeah, that's kind of. Yeah, let's go. This is interesting. Let's go ahead and.
What is it?
You can go ahead and take off the lasers and.
Looks like a spider web.
Looks like it has like
Yeah, and look, like there's another one. Look at the sit cam. It keeps going.
Because there is this
Maritza, nice photo.
Yeah, so I have a meeting, I think at 1 maybe, and then another meeting at like 7 o'clock at night.
Oh, so you can't just go to bed. Well, I guess you could have a nap.
Yeah, I just
But
think. Yeah, I think I just have to wake up around lunchtime, eat quick, and then. Okay. Yep.
It's
We
very
lasers
funny.
back on in transit then.
Very funny. Normally biologists are not too keen on like geological seafloor mapping, but I was been speaking to quite a few people this evening, or before they all went to bed, and everyone is very keen for a long mapping session tomorrow.
Yeah.
So I'm sure our geophysicist will be very
Lasers
happy
on.
because everyone wants a rest. So Sasha's going to be happy he gets to have a nice big
There they
map
are.
of the next station.
There they are. Perfect. Thanks.
What the rest of trying to get
Yeah.
right.
Yeah.
Actually, I find it very like relaxing to watch all the mapping. Personally, like on all the other cruises I was on, I'd often like just like sit there at the end of the day and watch the mapping. So, and really, you can't do your biology has what you can say about the patterns in biology are often less meaningful unless you do good mapping. So personally, I like a good mapping, not only because it gives me an opportunity to sleep, but because it's pretty informative.
But I think
So,
we've been
yeah.
quite lucky on this cruise so far because the maps we're getting are so high resolution. We're not having to do much mapping processing because I've actually got like mapping shifts as well on my mapping rotation. But at the moment, that just requires adding new files to the map on the computer, and normally you would need to do, there's like a lot of noise, so you'd have to like manually kind of delete it a bit like when you use Illustrator, Photoshop, like all these excessive dots. But these maps are so nice and clean, like I'm not actually having to do very much. So
Yeah, we've had overall very calm seas where we're at. I mean, we're in a protected bay basically, so that's certainly helping. And I think we've been pretty lucky. We've only had one major wind event since arriving on station, which really helps because this ship is so rolly and produces so many bubbles that when you have more than like 3 meters or so, the maps, like there's a lot of processing that you have to do. So
we also saw some of that on the transect, like through the
Yeah.
Drake Passage. The maps were very noisy.
And there's worms.
Indeed, who doesn't love a good mapping? I certainly do.
Yeah, see, I think that's why I enjoyed, I was really happy with my choice to get an oceanography degree instead of like a marine biology degree because, you know, I took geological oceanography, I took physical oceanography, and so I received exposure to all the different fields in oceanography and gained a greater appreciation for the role that each of those play and helping me understand and the drivers of patterns with the biology and how they all interact. So yeah, so for anyone out there considering going for a graduate degree, I highly recommend oceanography versus like marine biology if you're thinking you want to do biology focus. Just most programs give you a really strong understanding of ocean currents, ocean geology, as well as the chemistry and biology of the oceans.
I would agree. I think it's better to specialise a bit later in your sort of scientific careers. For example, at master's level or at PhD, it's good to have an overall view. This is the pink stone. Can we just get a glamour shot of that?
Yeah,
I don't
can
think
we
need to
go ahead and
collect
back
that
up
'cause
and
it's
look
very
at that?
large.
Yeah.
Or how large is it? Can we get a sort of...
Yeah, we'll take a look at it. I was thinking the same thing. It looked a little big, but
I'm sure Professor Rock would be happy, but...
But that is
fridge
a
is
big...
filling up quickly.
Oh, look at this, so big. It's dirty. 25?
Yeah, I think that's
so
too
yeah,
big to
it's
sample,
like
but,
25, 30 centimeters. Yeah. But if we can do a max zoom on it, it'd be great.
But yeah, I think especially if you want to become a scientist, there's a lot of science fields that actually kind of overlap each other. So, oh, thank you guys. That's very generous. I've just had the microphone moved right up to me to make sure you can all hear me clearly.
Beautiful waypoint. Thank you.
So, yes. I
You
think
guys sampling here?
No, we're just taking a picture.
All right.
Yeah, I think there's a lot of science fields, if you become an academic, where a lot of research actually overlaps between different sciences. So it's really good to have a solid maths background and also sciences and kind of a good understanding. For example, if you're physical scientists, it's good to do like physics, chemistry, and material sciences, and earth sciences can be very physical. And biological sciences, there's also various types of sciences, including also earth sciences, zoology, plant sciences, and your classical biology, biochemistry, chemistry. So it's good to get this general portfolio at that kind of undergraduate level before you specialise in things you're more interested in. It might also let you have a chance to like explore new subjects which you didn't contemplate at school. So you never know, you might change your career path.
Yeah, like
Like me.
economy speciality.
I mean, that is quite radical, but yes. What did you study, Anna?
I study biology science, but then I just specialized a little bit more on marine science because my university was not available in this course. So I went abroad, tried to work a little bit more and study a little bit more. And then I studied different. I actually took different.
You might want to
courses.
put the microphone up too so they can hear you.
Yes.
I also took different courses in oceanography and ecology and a little bit on geology, not so much because we're not allowed to, actually, as we said before, in Europe we are not actually allowed to mix too much because we have to choose some programs that are already established, so we are not so free to actually include additional courses that we would like. So I just took course by myself, and but it's not in my official program. But yeah.
So you guys all know more about rocks than you let on.
We can do it.
Maybe tomorrow we have a rock exam. We've already had a biology exam that had no right answers. So now maybe it's time for a rock exam, which also has no right answers.
Alright, thank you. That should be good.
Oh, wait, I missed that. Yeah, okay, I got it. Thanks.
She was distracted.
That's all right.
I got it. Thank you.
That's alright, I got
Okay.
a nice long zoom for you.
For you.
Yeah, we got it. Thank you.
You can always go back and watch the video later. I'm sure there's a few A snaps of it too.
I'll tell Professor Rock.
Who's Professor Rock?
Handpigs.
Yeah, Jess, you missed that we had the rock saw out on the deck today. It was quite fun.
Oh, I did miss it. Sounds very hardcore,
It's quite satisfying. Maybe at this point in the cruise, you just pretend who that rock saw is.
Jeez. That turned dark.
No, I didn't do any sewing, and that was just undressed. But it did give me some nice rocks, which maybe I have one. No, I took them out of my pocket now.
Alright, we're nearing waypoint 9. I'm still seeing a lot of exposed rocks as we're nearing the summit here. It's kind of like a little valley.
Yeah, we also just went quiet, so sorry that happens. Get a little distracted looking at what we're seeing, forgetting to have a chat.
Some beautiful rocks.
Yeah.
That's why the biologists are left speechless.
And the geologists.
That's right. I just can't stop looking at you guys. So I think this is definitely not an ideal location
For push core.
Yeah, look at it.
I know, we just as
I
soon
mean, it's written in my plan, but I think I will go ahead.
as yeah. Between here and waypoint 10, so
You're gonna drop into the south.
yeah. So probably when we hit the bottom of this will be a good spot. Alright, so we're going down a slope a little bit here, so our view of the seafloor is not going to be great. Wow.
Oh wow.
That's an interesting transect. Yeah, the feature. Oh yeah, great. Carlos put the map up. So yeah, we're like going down into this like valley saddle. Yeah.
We have nothing to hide. We are eating some chocolate right now.
Cereal bar or
And the cereal, it's chocolate cereal bar.
Ah, you see chocolate.
Yeah. With the acoustics in this room, there's no real hiding when you're eating.
Well, you know,
You can hear every chew.
3 and a bit hours later. It's required.
Yeah, I have no shame in admitting when I'm eating. Just like forewarning you, you might hear some jumping and crinkling.
Actually, that chocolate errand that you've got, that's really noisy, like in the real life thing. I think it's that she worse than my cereal bar. Oh no, don't do that. It's painful to my ears.
Yeah, whenever someone drops something.
Здесь у нас кто-то русский.
You can go ahead, of course.
This is the comment in Russian. Если хотите, можем вам что-нибудь объяснить по-русски, пожалуйста, задавайте вопросы.
Silence. There was a moment.
Just the aim of excitement.
Mm-hmm.
I'd like to hope my Russian is a bit better than my Spanish, but we'll never know. Preguntas. At the end of in our science, we have a daily science meeting, and I'm organising these science talks. At the end of the science talks every day, I've become very good at saying preguntas. Good practice. Preguntas.
It's just so funny because, like, in Chile it's consulta or.
A consulta.
Oh, it's not preguntas?
It's not pregunta. No
Oh.
way.
Uh-huh.
No way. There's
So-
consulta. This is a new word.
Consulta.
Let's hope I remember it at our science meeting tomorrow.
Consultas. Oh my.
Yeah.
And
Preguntas
if
is
you're ready, I
like
believe you're
too
next on our
formal.
schedule.
Mhm.
Yeah.
Is
No,
you,
next,
you're ready?
not today.
Yeah, today.
Oh no.
It's
What's
your turn
math?
today.
Math.
Oh yes, you're right, it's Matt first. And plus he's donating the cause, right? So he'll be more rested than us.
Yes,
So
Mhm.
exactly. I will do tomorrow.
tomorrow.
Yeah.
Perfect.
Is that why he donated the chorus?
He was
get rest.
mortified for his yeah, it actually is.
He was too tired to
That's
get
what-
more
yeah, you
calls.
said, do you want my cause? And I said, yes, I love sediment. Dr. Sediment wants sediment.
And not rock.
Occasional rock.
Whoa, whoa.
Oh, that's interesting. That's a super cool feature.
Can we look
Yeah.
to the right a little bit?
Are we able, yeah, as we go down, are you able to look to towards one of the faces. Thanks.
Cool.
Actually, can we zoom in on that right there? I think it might be like a hydrozoan, but
Aaron, hydrozoans related to bryozoans, so the names just sound similar to make them confusing?
Good question. Don't know exactly how closely they are related.
I'm not sure who made us this dive plan, but this area is not good for push cores. Which you can see on this map here actually, like, you know, the topography map, you can see that the waypoint 9 is like in the middle of this trench.
And like point 10
with two rock walls, and waypoint 10 is even worse on the side of a rock wall.
Well, we are flying over the watercolor.
It's rock monstrosity.
We need the feet. Oh,
Like, to be honest, to me it looks like it's probably only up to like maybe waypoint 12, that area, maybe it's like a bit flatter on that left hand side than these ones on the walls.
Yeah, I can.
Yeah, very.
10 is possible. 11 is here.
Yeah,
and
that's
it's practically impossible.
Yeah, so maybe it's maybe there, but who knows? Oh, we could go back to where we got Teresa's things.
We go back to that place.
Oh, I don't know, because that had like sediment.
Yeah, I don't know what's going to be at the bottom here. I mean, there's a pile of sediment, so.
We can try it.
Yes, it depends how deep this trench is.
600.
No, as in how deep the trench is, how much sediment got into it, whether it's just the surface kind of cover or.
It's looking like it's pretty deep. There's a nice
sediment pocket.
Yeah, around the base of that cliff, so.
Maybe this would be a location for my gravity core.
Between the.
Actually, the next gravity core, we're thinking of doing a 6 meter one because we've got such good gravity cores so far, and we have 2 barrels that we can actually deploy 6 meter equipment. But the reason we haven't done that so far is because each barrel is 3 meters, and we were really worried that the barrel would bend from all the rocks, and then if we bend like both, so if we did the 6 meter and both broke, then we can't do any gravity core. But now we want to risk it and get a nice 6 meter long gravity core. That'd be super cool. Have to stretch it across the whole deck.
6 meter in one. Double check, because the last in the first check happened because in the first lap they tried and they couldn't.
But I think that was much deeper water depth, so actually I think that was around 3,000.
Yeah, it was.
Yeah, but it's because of the weight and the winch that they
Yeah, we're
couldn't
gonna
do it
need to
with the
get
current
push
winch that
cores,
they have
so
here.
I don't know. It's like kind of steep here. Is that gonna be an issue or?
Apparently here, yeah, I think they think it should be. But then it's like the risk, you know, of like breaking it. But I think because we've now collected loads of good sediment, and the last gravity core is actually.
Pause and move, please.
Pause, move.
Was 4 meters because they penetrated, so it went into like the backup section. So actually, from that, we were thinking that if that worked, maybe we could try for 6 meter.
Yeah, that would be nice to see. And then I would use
the color book.
The color
oh
book.
yes, you've done the color book. Actually, I think quite a few people had some fun. So there's a book called the Munzel Soil Color Chart. This book is actually quite expensive, costs around $300. And it's basically like a palette of all shades of brown and grey, so that you basically go around. Yeah, compare that's true. Compare it to your sediment, and you kind of have to watch out whether it's got red hues or blue hues, and try to find which one it matches the best. And you note down the colour. It's kind of like a universal code. The reason this book is so expensive is because the colours have to be perfectly printed each time. This perfect colour, calibrated, on special printers. So yeah, and then you can learn something, you know, about different colours of sediment.
Of course. To become master student in Sediment.
Exactly.
Okay.
Alright, it's probably anywhere around here.
Alright.
Right.
It's gonna be good.
Alright, sounds good.
Have we done the push course?
Yes, we're gonna try to do the push course
So
here.
do you want me to log them like as we stick them in or as we get them out?
As we get them out.
Yeah. And do you wanna try first to see? Because we need to
Yeah.
close the skin bottle before starting. Before it's better.
Okay.
Are we doing the 3 extra longs here?
Yes, we'll do the 3 extra longs, all 3, and then we're gonna do 3 of the regular ones. We'll how many push
No,
course?
so-
4. 3 plus 4. 4 will be.
No. So it's because one long one is for Andres, so it's 3 long ones full and then 5 short ones full.
And then 5 short ones full. Okay, thank you.
Thank you.
Yep. Yeah, and we'll get a Niskin bottle before.
So your next bottle is here. That's daytime.
I know Anna's been very kind sharing her skin bottles because I was very upset we don't have the sea to do and I need the bottom water sample to compare to my pool water measurements.
Skin 2.
And this is the skin too?
Yeah.
So for those that don't know, Niskin bottle is this special kind of bottle that traps the seawater sample from wherever you choose to shut it. It fits around 10 litres, Anna? How big are these?
This is 5 liters.
Okay, so these bottles are 5 litres. And it actually then brings it back to surface, so then we can use the seawater sample to investigate, for example, chemistry and such.
2.
And
Niskin bottle 2 was taken for logging. Alright. Yes, so we will do the other 17 push cores here with the 3 long ones going to the top and then 5 additional ones going to the top. All the rest will have those couple of inches or 3 to 5 centimeters or so of water. They need to be at least half full for the others. Looks like there's going to be lots of little bits of rock in the cores.
It's going to be fun to extrude.
Andres is going to have lots of little rock samples.
Excel's a long way, right?
Yes.
Oh yes. This actually Sunny gave it to me earlier. It's quite nice, this one. It's like a dark chocolate with some orange. I should pass it around. I don't know why it was still here.
Something that I don't think anyone likes, right?
You don't like dark chocolate?
No, with orange with it.
Oh, I see.
It's okay. I just set my favorite with orange.
That
It's
looks like a
pistachio.
very nice juicy push
Available.
core.
Ooh.
It's really nice.
Confirmation that the sediment is deep enough to get all the cores here. And that the rocks aren't interfering. The little rocks. Alright. 1 down, 16 to go.
I've not been on an ROV shift yet of this push course. I've only watched it from my bed.
Yeah. I haven't been watching the push course from, but I haven't been on. This is my first on shift too. Yeah. I mean, at least on this expedition, I've been on shift a number of times during push coring.
Nice. So I think it's very cool that we were able to get a few slightly longer push cores, because those extra 10 centimeters can add like sometimes 100, sometimes like 500 years to a climate reconstruction actually. So for us it's actually excellent.
So which station has been the most interesting for you when you've been looking at the push cores? That like makes you the most excited?
Well, I don't actually do too much with them on board, apart from like, you know, changing containers if you like the liners and bagging them up so I can take them home. But I do try and sieve like some of the excess, so I really enjoyed like this Station 16 just because I was not expecting to find any of those farms at all in there, but we've actually found quite a few, so it's very interesting. And as well as like sub-ice essentially conditions, so I'm really looking forward to kind of getting deep into the sediment when I get back home, or rather hopefully get some students to help out. I've submitted a couple of master's proposals, student proposals, so to start in September next academic year to do some studies on these sediments from this cruise. Days ago, so I'm hoping to start getting some emails of interest, but we shall see. Well, yeah, it was advertised like 5 days ago, so I have not yet heard from any interested parties. But generally, I tend to do normally a lot of teaching in this Lent term, which is the term for us that starts in January and goes on until Easter. That is my prime teaching term for all the climate classes. So I teach a lot of like environmental maths, quantitative environmental maths throughout the whole year. And then most of my climate teaching and oceanography teaching is this term. Unfortunately, I missed half of it because I'm currently on the cruise. But this is a really good chance to recruit students, because through this like small group teaching, essentially, you know, sometimes you like get on with students and become interested, and they become interested in your research, and then they want to do these master's projects with you. And normally I don't just do like the class, so I normally try and do a little lab tour. Like I've taken them to a Earth Sciences Museum before, just, you know, for like little 10-15 minutes out of the class, because I think it's like nice to be inspiring to the students, you know, and get them like really interested in our field and stuff we do, like get them to stay in science and just show them, you know, what actual science is, because it's very different from like what the textbooks and the lectures they go to.
Definitely, yeah.
And they always get very excited when I'm like, hey, you want to look through the microscope? Like, check out these guys. So it's good. I quite enjoy teaching.
Yeah, I do too, actually. It's part of the reason I ended up deciding to go the professor route, is you can still do some teaching, and I actually prefer hands-on, like the hands-on teaching, like the in the lab teaching. I really enjoyed on prior cruises having a lot of students, and providing them with a like real world like experience instead of just learning about it in the books. I took an undergraduate student from my university, and it's funny because interesting to me, I guess, that the next semester after she was on the cruise, or later in the semester after we got back, she started learning in class about CTDs, but she was actually able to participate in, you know, CTD water sample analysis and like see one being operated while she was on the ship, before she ever learned about like the theory and everything behind it. So yeah, it's really interesting to see students engage that way. Ooh, I almost flung my pencil.
Can I do that?
Yes.
Thank you. Can I make a note? Which numbers were they? 5?
So I've been writing, it's, yeah, 5, 6, 7, 8.
8.
Yeah. And 9 is going in now.
Oh, perfect. Thank you.
Mm-hmm.
nice for when I'm tired later in
7
the
and
morning.
6 are long.
Yeah, and number 3
Yep.
is it. Cool. But did you, Erin, on the previous cruises on the Falco, because I know you've been a few times, did
Mhm.
you have students with you then on the ship?
Yeah, we actually had on our first 2 expeditions, we had between a third and a half of the science team were students, and that included undergraduate students. So Maritza was on all those expeditions with me, and we also had some master's and PhD students as well, but we probably had 4 to 5 undergraduate students, largely from Chile, 1 from my institution in South Texas, and then we had a number of master students, a couple of PhD students, and then mostly early career researchers, only a couple of full professors on board. So
That's cool.
yeah.
I think even this cruise is actually so nice, the opportunity, all of us, like, we don't have that many, like, old professors here, you know, a lot of us are early career still, and it's even, like, I know you're a prof, but then, I don't know, would you consider yourself early career?
Yeah, I'm still early career.
Yeah.
I'm assistant professor, so
Yeah.
I'm not tenured yet. So, yeah.
But it can be sometimes, it's like, when does early career end, you know, or what is,
Yeah.
because sometimes, like, there was this one conference I went to recently, and I went to the early career event, but it only had, like, grad students there, and a lot of masters especially, not even that many PhDs, or, like, early PhDs, and then I was a bit like, oh, I think this is not my vibe.
Yeah.
So you never know, like, I find early career stuff hit and miss these days, actually. I don't know if you guys get the same thing.
It's different. Sometimes they consider early career by age or by the years of after your PhD, and it's variable. Like sometimes they consider 5 years, sometimes 10 years. So it's
Yeah.
like it's not easy.
In the U.S., it's pretty consistent that as long as you're an assistant professor, you're definitely still considered early career, at least in academia. But they do often put 10 years since you obtained your PhD, which now is pretty close to when you might become a tenured associate professor in the U.S. And
No, it's quite crazy, right? How
Yeah.
long you've got to do all this stuff for before you
Yeah.
actually get, like, a secure permanent job.
yeah, and it's also like you know you're still early career when you get reviews back that are like, well, for an early career researcher, this is well written. And you're like, hello.
Thank you and goodbye.
Like
That's what I say.
yeah, exactly. It's like, well, I'm gonna take your review with a grain of salt. So yeah, I think
So now
yeah, there was mostly, I was one of the few professors even on our cruises. So we had two or three full professors, and then everyone was assistant professor or lower, mostly postdocs or research associates and students. So this should be the 5th one that's long,
Yeah.
I think, right? So,
Yeah.
Okay. So yeah, basically it's 5 through 11 are the geology course, plus 3.
okay.
So after this, you want for 12 onwards, we want to do them with water on top?
Yes.
Yes.
For 12 on water on top.
Okay. So 6 I put right now because 6 and 7 long. 5,
Yeah.
8 and 9, 10 and 11 shorter. Oh, Sveta.
Thank you.
Because otherwise I will forget.
And you said to log these once they're coming up?
Yeah, once they're coming out in case they have to retake it.
Okay.
And we did the geology ones first, so I know sometimes she gets gets a different one because the biology ones were taken first.
Wow. So,
Fish color party.
it's the best part.
Yeah.
How much water do you want there?
A little bit deeper. Let's aim for about there.
for most of them, yeah. I don't think they... Yeah, they just have to be at least 10 centimeters deep and have at least 3 centimeters of water. So... I think the next shift is going to be disappointed that they weren't here for the push course.
Oh, yeah.
Sorry, we got to the waypoint before your shift. Looks like there's going to be a lot of rock, like cliffs coming up after we do the push coring. Go up a cliff, back down, and even deeper, steeper, probably. Back up.
Push-core effect. I'm thinking about breakfast.
I'm not hungry.
Maritza. Oh, yes.
I did think that after not really sleeping during my very small sleep window, that I could have been quite content to wake up to Ben's waffles, but it was too late. Already off.
Are we talking about breakfast?
Maritza started it.
Maritza. Reina. Por favor. Yeah, no, my daily aim is to go to bed before breakfast, but every day it kind of just escalates.
Yeah.
We don't have anyone.
Yeah, I'm contemplating trying to take a power nap before the ROV comes up. I was originally going to go work out again, but...
I was close to that yesterday at 5 o'clock in the morning, but then I thought, no.
Absolutely.
Well, no, I was like, oh, I'm really up for it. I'm just so awake. But then I was like, no, if I do that, then I don't know when I'd fall asleep. So, yeah. But I'd say if you want to, I could wake you up at 6:30 or whatever if you want to go sleep for a bit. If you're scared of folks sleeping.
Yeah, I'm pretty good at waking up to my alarm. It's just, I'm a little worried that if I go to sleep, then I might just feel a little bit worse, but...
That could happen. Yeah, I'm so bad at waking up, I think half the ship has now heard my alarm, so I apologize if anyone in this room has experienced. First time Laura heard them, my cabin maid. She thought there was evacuation going on.
Oh no.
I have 3 really rowdy, sinister alarms that just keep going off, and sometimes I just keep sleeping through them,
Evacuation alarm.
Yeah, I can't imagine. Today I couldn't sleep because there was someone walking on the floor above. It sounded like someone just stomping their way through. What? Walk gently.
So, for those asking, we have 20 push cores on the vehicle right now. I think you could, in theory, actually fit more, but that would be sacrificing some of the biological boxes, etc.
Sacrificer?
Actually, I think they're capped with they don't have enough pieces to convert the quivers to cores.
Okay.
I think we might have been limited by that, but Andy can correct me if I'm wrong.
Well, yeah.
Maybe they could have put a few more on, but okay.
I would like to use
Yes, because you're not interested in any push cutters, right, Anna? You're not.
Me? I love a push cutter.
You love a push cutter.
I really
That's
love.
excellent.
Deeply.
Me too. Hence I'm getting 7 this morning. It's gonna be really good workout. Erin, I think you should start coming to the hangar to help you with push cutters, and then you won't need to ever go to the gym again. It's funny.
I have sliced many a core. Yeah, they actually, my first expedition ever, we were doing multi-cores for my PhD. It was my PhD work. I was doing my master's at the time. But yeah, we sent the multi-core down, and I sorted many samples looking for harpacticoid copepods.
And that sounds like exactly the kind of the right person that I need. Very experienced.
I did granulometry, and now my students, my students are done with all their collection and just wrapping up their analyses now. But yeah, we did hand push cores in an estuary by our university. It's a hypersaline estuary, so we're conducting the first analysis of the meiofauna in that estuary right now. But they did most of I showed them how to slice the cores, and then they took it from there. Yeah.
That's quite cool.
Yeah. No, we still do some coring work for sure in my lab. Easier to do it coastal. It doesn't cost as much money to get out there and get the samples. So, yeah.
Next time I go on a cruise, I really want to deploy this giant casting core. So there's an emeritus professor in my department in the university, and he's got one of these guys that is like a really big square barrel, and you can basically have like many subcores from one big fat thing of sediment.
Nice.
And potentially, he said I could borrow it for this cruise, but I just didn't want the responsibility. I didn't have the money to like.
Yes. Yeah, that's good.
Am I meant to be taking a picture? Do I need to do a picture?
No, there'll be an A-snap of it.
Okay.
I don't think it's not written in the protocol.
Okay.
No problem.
So now I start logging when we put them out.
Yep.
Yeah, that is important. I mean,
Now's the
get focus, please.
Pay attention. Stop talking.
Oh my.
Yeah, we usually respond to your questions. We don't usually do a lot of as many written responses. That's less frequent. Let's push core 20. TC 642.
I'm now really looking forward to my third dinner of the day.
Right after shift ends.
Exactly. 18 minutes.
It might be right around the time we're finishing the coring. I see 6:43.
I can't be.
Correct. Full marks.
A long life.
CTC 644. Fish wants
What's
to.
happened?
The
I'll
fish
buy
is
your
trying to
sample.
get in under the push core. I'll
Buy
just
your
log the
sample.
fish as a push core. Perfect. You have a rocky fish and a pushy fish.
That would be very easy to find in the sea life.
Erin will be so happy with me tomorrow at the science meeting. I'll get a long lecture.
I don't know why. I gave one. Please.
Very long telling off at the science meeting.
Please log things correctly for the corals. One time. They never had to be addressed again. But Savette is obsessed with it. And I didn't direct it. I said it was general. I didn't even know who did it. I didn't even
wasn't
look.
me, I told
okay,
you.
well there you go. See, I don't know who did it.
It was before we did any of our ROV shifts actually, so it's definitely not me.
Oh yeah, that would be true.
Because we didn't have any for a while, right?
We didn't, yeah. We were in a
until they changed the
mission
schedule.
control drought.
I quite like this shift. I think it's more fun than my previous shift now, because now I do this 2 in a row.
Yeah.
Woo!
Countdown.
It's the final countdown. And no, I'm not going to continue. I feel like Maritza, you might be good at singing.
No.
No. Absolutely not.
Where are we at right now? It's a good question. We're right around 73 west and 73 south. I don't know the exact coordinates right now, but
Very okay.
yeah, so we're in the Rhone entrance essentially of Antarctica. Pretty much at like the southwestern point of that bay.
This is 14, right?
Yes.
Anna?
Yeah, this is 14 and I think
He's doing them all in order.
he did them in order, okay, because that one looks like it says 13 but on it, but it was a 15. Okay.
Sorry, so which one is this?
This one was 14 that just went in. It's just a little confusing because that one says 13 on it. There's 2 13s? Okay.
That would be easy then.
Someone here really likes Friday the 13th.
Okay.
There's a lot of fish in this area whilst we're doing push cores.
And then the other 13.
So this is actual 13.
Yeah. This is like solid 13, the other one's just outline 13.
Okay, now
They're making a 3 and a 5 with
the last one.
Yes, so.
And then it's beta.
Yeah, so these are all bios.
put it in the group chat, like my course, you know,
Yeah.
the ROV things, so people don't take
Yeah,
them
and
in
then I
case
already put
yeah.
your
So I've had that problem a few times, and then they complain. They think the push core is broken, that's why it's longer. And I'm like, no, it's longer because I want more sediment. Give me a couple of hours to sleep, please.
Yeah, I'm also writing all the bio ones on here, and I'm gonna put your name on in all of these.
It's just the initial.
But yeah, we can definitely put in the chat. It's basically
I'm logging twice.
3 and then
I mean, it's a pain.
7. Yeah.
This have to do Maritza and this is yours.
It's mine?
Yes.
And I thought it was Maritza's job.
Maritza is big on this one, but I can do it. So you can keep talking.
You're like, I just don't want to talk. I was filling all the paperwork. It was number 11.
It's 4.
That was 9.
Is it 9? Okay. Well.
Because they are trying to keep
Okay.
the same position.
Thanks. I thought it was a 4. 9 UTC.
9 is yours.
It was 9. And this is Sveta's.
10.
This is 10. UTC 650. Oh yeah, it's so much clearer in the SICAM.
Wait, which one is this? I really can't see.
Yeah, it was, yeah. Just making sure they're in there good so you don't lose your sediment on the way up. UTC 651. This is number 11 coming in.
Yeah,
Number
it's
11?
11. Yeah, it's yours.
Alright.
Yeah, yesterday I was hungry for rocks. Today I'm feeling really greedy for the sediment.
Said 8 to 22 for you. 8 to 11.
How you describe the push cores as juicy. Juicy